All right. Shall we start, guys? Hello. Let me join with my phone also. Just 1 minute. I'm just joining with my phone. Oh, guys, I'm
Guys, am I audible?
Yeah, yeah.
great.
Great.
Okay.
Okay.
So
So
coming back
coming back
here,
here,
so we are
we are
starting week eight
starting week
as
eight
we
as we
told. Even
told.
if you are
Even if
not
you have
watched
not
the
watched
lectures,
the
it's
lectures,
also
it's
fine,
also fine,
right?
right?
Hmm.
Mm.
So
So
I think
I think
Afnan and
Afnan
Uma,
and Uma,
how many
how
were
many
covered in
were
the
covered
live
in the
sessions
live
and
sessions
which
and
you want me
which
to
you want
cover?
me to
Because
cover?
tomorrow is
Because
the
tomorrow is
deadline,
the deadline,
right?
right?
Probably.
Probably.
At least the
At least
concepts
the
you need to
concepts you need to
understand.
understand.
No, yesterday again, I think they covered almost all. I think I was not until median. I was there,
Okay.
Okay.
but I think in the closest pair, I didn't understand. You can.
Let's ask
Let's
others.
ask to others. Mahi,
Ravina,
Ravina, you have any
what to
suggestions on
do?
what to do?
So deadline is extended.
So that means
So that means
what do you want to
what do
do?
you want to do now?
That means
That
probably
means
we'll have
probably
one
we'll
more
have one
session
more
for
session
weekend.
for week eight,
That means
right?
on
That
Tuesday,
means on Tuesday,
right?
right?
So
So, Uma, shall
go
we go with I mean,
two,
two
we'll have
we'll have two
sessions for
sessions for
weekend,
week eight,
right?
right?
We'll go
We'll
from
go from
the order
the
only.
order only.
Yeah,
What do you
Works?
works?
yeah, yeah. I didn't understand the closest pair was very tough. So if everyone is okay, we can go through it.
Mm-mm.
Or let them suggest.
No, no, no,
Then
no. We'll go from
we'll
the
go from the like starting only. That's
good
the
way,
good way,
right?
right?
So
So,
I just
I
want
just
to
want to
volunteer
volunteer
here.
here.
Okay,
Okay, so
okay, it's fine.
okay, fine.
There is this
There is this
concept of
concept
divide
of
and
divide and
conquer.
conquer.
It's
Okay,
a,
it's a
strategy or
strategy or
methodology to
methodology
come
to come
up
up
come up
for
with a
come up with a
solution.
solution.
For
For
example,
example,
can someone
can
else read
someone else read this?
Mahi,
Mahi, Nishkash,
Vicky,
Vicky,
Uma?
Uma.
Yeah,
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 I can.
Nishkash,
Yeah,
because if
Nishkash.
you read it,
Because
So,
if you read it, then
di-
you can understand.
divide and conquer is break up a problem into disjoint subproblems
correct.
Correct.
and then combine these subproblems solutions efficiently.
Hmm.
Hmm.
An example merge sort, split into left and right half and sort each half separately. Merge the sorted halves. And
Yeah.
in quick sort, rearrange into lower and upper partitions, sort each partition separately. Place pivot element between sorted lower and upper partitions.
Hmm.
Hmm.
So,
So,
did you
did you
understand,
understand,
Ravina,
Ravina,
Mahi,
Mahi, Vicky,
what's happening?
what's happening?
Nishkash also,
Nishkash also.
what it
What
means?
it means?
Mahi, yeah, you
Mahi,
were saying
yeah, you
something.
were saying something.
Mahi,
Mahi,
hey, please be
hey, please be
interactive.
interactive.
No.
No.
Yeah.
So, what do you
So,
get
what
out
do you
of
get out of this?
You just simply divide the work into sub work and then combine the sub
it?
them.
Yeah.
Yeah.
Can someone
Can
tell,
someone
tell me
like
the
tell me the
concept of
concept of
merge search?
merge sort?
How do we do
How
the
do we
merge?
do the merge sort?
Doesn't
Doesn't
Mahi, you know
Mahi, you know
how merge
how
search
merge
works?
sort
Yeah.
works?
We divide our list.
Okay, let me take
Okay,
a
let me
list.
take a list. All right,
Two,
two,
5,
five,
3,
three,
4,
four,
8,
eight,
7.
seven.
Right?
All
So
right.
this is
So
what
this
the
is
list
what
is.
the list is.
Tell me,
Tell
how do
me,
you do the
how do you
merge?
do the
What
merge
is the
sort? What is the
algorithm?
algorithm?
How do you
How do you
do
do
it
it? Do it
actually?
actually.
We divide our list into two halves, left array and right array.
Okay, so that
Okay,
means
so that
2,
means
5,
two,
3,
five, three,
right?
right?
The right hand
The
side
right
will
hand
be
side it will be
4,
four,
8,
eight,
7.
seven.
Okay,
And
Okay.
then again left into two parts, 2, 5 and 3.
2,
2,
5,
5,
3,
And then 4, 8 and
4, 8,
4, 8,
and then this is 7.
7.
Yeah,
Yeah.
okay.
Okay.
So then,
So then,
so when we
so
have,
when we have,
tell me.
tell me.
until we have single digits in every array.
Acha, okay, so
It's
I,
2, 5.
2,
2,
5.
5.
This is okay,
This
right?
is okay, right?
Yeah.
I think this is
And this
4
is 4
and 8.
and 8.
All right.
All right.
Hmm. So then what
So
do we
then
do?
what do we do?
And and then we start merging these.
Mm-hmm.
Uh, so 2 and 5 is in correct order. We
Okay.
merge it.
Uh-huh.
Uh-huh.
So we merge
So
it,
we merge it,
and
and
so how
so
do I write
how
it?
do I write it?
Should we write it
Should
here
we write
only?
it here only?
Is it fine?
Fine.
I'll put 2
I'll
comma
put 2
5.
comma
Is it
5.
okay?
Is it okay?
Hmm?
And 4 and 8 is it also correct order, and then we compare it with 3
Mm-hmm.
Hmm.
and put 3 in the middle, in become 2 3 5.
Mm-hmm.
Hmm.
So
So
how does
how
this
does that
happen? Do you
happen?
remember
Do you
that is
remember that
what
is
the whole
what the whole
logic is
It's
about?
logic is
like
all about?
pointer thing.
Uh,
First, we check 2 and 3, compare 2 and 3. So 3 is greater. So, sorry, 2 is less. So we put 2 first,
mm-hmm.
and then we compare 5 and 3. Whichever is lesser, we put 3. Here 3 is lesser in 5 and 3. So we put 3 and then 5.
So that's
So that's
basically
basically nothing but
merging
merging
two
two
sorted lists,
sorted lists,
right?
right?
I mean,
I
we will
mean,
have a
we will have
sorted
a
list:
sorted list:
4,
4,
5,
5,
9.
9.
So these two
So these
are
two
these two
are these
sorted
two
lists?
sorted lists?
Is this
Is
sorted?
this sorted?
This is also
This is
Yes.
also
sorted.
sorted.
And how do we
And how do
sort
we
these two
sort these two
sorted lists
sorted
into a
lists
single
into a
list?
single list?
First, compare 1 and 4.
Correct.
Correct.
So
So
1 is
1 is
lesser.
Hmm. One is
1
lesser,
is lesser,
and we move
and
the
we move
pointer
the
And
to the
pointer
next
to the
one,
next
right?
one,
move
right?
the pointer to 3.
Hmm.
And we compare 3 and 4. 3 is lesser, so 3.
All right.
All right.
Move the
Move the
pointer
And
here.
pointer here.
then 7 and 4. 4 is lesser than 4.
4 is lesser
4 is
than
lesser
7.
than 7. Yeah.
Yeah.
Mm-hmm. Then the
Then
pointer
the
And
goes
pointer
then
here.
goes
move
here.
the pointer to 5.
Mm-hmm.
And we compare 5 and 7. 5 is lesser, so we put 5.
All right.
And then we compare 7 and 9.
Mm-hmm.
7 is lesser.
Okay.
Okay.
And then we compare 8 and 9.
8
8
and then 9.
and
8
then 9.
and 9.
So this is
So
what
this
is
is what
happening
is
at
happening
every
at
step,
every step,
at every
at
merge.
every merge,
Right?
right?
In this merge
This
also,
merge
this is
also,
what is
this is what
happening,
is happening,
right?
right?
And the same
And
kind
the
of
same kind
procedure
of
is
procedure
happening.
is happening.
Yes or no?
Yes or no?
Yes.
Okay.
Okay.
4,
4,
7,
7,
8,
8.
and then
And then
these two are,
these two are,
this list is
this list
sorted
is
and this
sorted
is
and this
sorted,
is
so we
sorted.
merge it
So we merge
together
it together
as a single
as a
sorted
single
list.
sorted list.
So
So
basically 2,
basically
3,
2, 3,
4,
4,
5,
5,
7, 8.
7,
So
8.
this is
So
what is
this is what
happening in
is
the merge.
happening in the merge.
So this is
This
strategy.
strategy,
This is
this is the
divide and
divide
conquer
and conquer
strategy. So
strategy. So
basically,
basically,
we have a very
we
big
have a very
task.
big
Like we have
task.
like
Like we
a
have like
thousand.
a thousand. Like
Here we have
here we have
six elements
six
list,
elements list,
right?
right?
We
We
divide it into
divided
small
into
small
small
pieces.
small pieces,
Solve small small,
small
and then
small,
at the
and then
end
at
you
the
come
end
up
you
with
come
a
up with
very good
a very good
solution. I mean,
solution. I mean,
which is the
which
required
is the
solution,
required solution,
right? So this
right?
is
So
what we
this is
call it
what we
as
call it as
divide and
divide
conquer.
and conquer.
So another
So
example
another
is quick
example
sort,
is
but
quick
let's
sort,
not
but
go
let's
there.
not go there.
Let's go
Let's
if
go
you're
if
going
you're going
like it'll
like
be
that.
too
It'll
much
be too
time.
much time.
All right.
All right.
Okay.
Okay.
So
So
does anyone know
does
about
anyone
this
know about
counting
this
the
counting the
inversions? What
inversions?
is this
What is this
inversion?
inversion?
What does
What does
inversion mean?
inversion mean?
Uma, have you
Uma,
watched?
have you watched?
I think
I
you
think
have seen
you
that,
have
right?
seen that, right?
No, 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 I forgot. This
Okay,
time I
Okay.
haven't watched the lectures. Sorry.
it's fine.
It's fine.
So Afin,
So,
what
Afan,
about you?
what about you?
Uh, so
What?
what do we do is, am I audible?
Yeah, yeah, you're
Yeah, yeah,
audible.
you're audible.
So what do we do is basically that we have this ordering, right? So in this case, we can see that this is 1, 2, 3, and 4, and 5 also.
Mm-hmm.
And the other, on the other side, we have 2, 4, 3, 1, 5. So what essentially we do, we compare each of the pairs that are there, I comma j, as it is written here also. And whenever I is less than j, and in the other set j appears before I, which means essentially means that the order is like flipped. So whenever it is flipped, we count it as one inversion, right? So similarly, we'll do it for all the pairs that are possible, and then we'll finally report the total count of such inversions. So that will be the count, total count.
Okay.
Okay.
So
So
I kind of
I kind
understand
of
what you're
understand what you're
saying, but
saying,
what does
but
this
what does
picture
this picture
represent?
represent?
Okay, so this picture I think is representing wherever we have this, like 2, we have this another 2. So I think whenever this intersection happens, that indicates one inversion.
Hmm.
Hmm.
So if we just count the dots, I think we'll be able to get the total count of such inversions, is what I believe.
Yeah, yeah,
Yeah,
But
yeah,
not
yeah.
very sure about that. Yeah.
That's right.
That's
That's
right.
right.
That's right. Actually,
Yeah.
Let me
let
go
me
to
go through
the
the
slides.
slides.
Right?
Right.
Of Week 8.
Because I think the intersection can only happen when there is a flip happened there. So without the flip, you cannot have that intersection. So I think, and that essentially is giving us that it has changed. The order has changed. So if you just count the intersection points, I think that will be the total count of such inversions.
Hmm.
Mhm.
Okay.
Okay.
So they are
So they
given
are
an
given an
example, right?
example, right?
Yeah.
Okay.
Okay.
So we have
So we
online
have online
services
services
recommending items
recommending
to us,
items to us,
right?
right?
So we have
So we have
profiles with
profiles with
other
other
customers.
customers.
Compare your
Compare
profile
your
with other
profile with other
customers.
customers.
Identify people
Identify
who
people who
share your
share
likes
your
and
likes and
dislike,
dislike,
recommend them.
recommend them.
So
So
comparing profile.
comparing profiles.
How similar
How
are your
similar are your
rankings to those
rankings to those
of
of
others? Okay.
others? Okay.
So
So
comparing
comparing
rankings,
rankings,
you and your
you and your
friend rank
friend
five
rank five
movies.
movies.
So for
So for
example,
example,
I rank in
I
this
rank
order.
in this order.
We have five
We have
movies:
five
A, B,
movies: A,
C,
B,
D,
C,
E.
D, E.
Okay.
Okay.
So I'm
So
ranking
I'm
that.
ranking that.
Okay.
Okay.
I like
I
the
like
D
the
movie.
D movie.
I like
I
the
mean,
D
I like the
movie
D movie
very much.
very much.
Then comes B,
Then
then
comes
comes
B,
the
then comes
order,
the
and
order,
this is my
and this is
friend's
my
order.
friend's order.
Okay, someone
Okay,
else is
someone
doing
else
that.
is doing that.
How do we
How
measure
do we
the
measure the
similarity?
similarities?
How similar
How
are we?
similar are we?
Okay, for
Okay,
each
for
pair of
each
the
pair of
movies,
the movies,
compare
compare
preferences.
preferences.
Okay,
Okay,
let's go
let's
down
go down.
and check.
Check.
I think
I
here
think
we
here
are.
we are.
Okay.
Okay.
Um, let's take an
Let's take an
example.
example.
Right.
Right.
So
So
A,
A.
B, C, D, E. Okay.
Okay.
Mahi,
Mahi,
you're here.
you're here.
Ravina,
Ravina,
hello.
hello.
Yes.
Yeah, Mahi.
Yeah, Mahi.
Can you
So
just
can
tell
you
me
just
an
tell
order?
me an order?
Can you just tell
An
me an
Just tell
order
order?
me an order.
means
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 tell in
tell
any
in
order.
any order.
Just tell me
Just
some
tell me
order.
some order.
Like
Like
okay.
if
Random.
yeah, any
yeah,
random
any
order.
random
Just
order.
C
Just
C,
C B A
B,
B,
A.
A,
D
Huh?
huh?
D E
B already
B
we have.
already we have.
You just
You
tell
just tell
D
only
E
one.
what you want.
B,
D
B,
B and
B
E.
and E.
Okay.
Okay.
Mahik.
Mahik,
Sure. Okay.
okay.
Someone else
Someone
want to
else
tell
want
it?
to tell it?
Ravina, would you
Ravina,
like to
would you
tell
like
me
to
an
tell
order?
me an order?
Hello,
Hello?
Pooja,
Pooja?
Uma.
Uma?
Yep.
Yep.
Yeah, Ravina.
Yeah,
Tell.
Ravina. Tell.
Yeah, Ravina, you
Yeah,
can tell.
Ravina, you can tell.
Sir, I'm listening. I'm trying to focus.
No, just tell me some
Just tell me
order.
some order.
When you
When you
interact,
interact,
you will have
you
more
will have more
focus.
focus.
EDCBA.
E D
E D
C
C
B A. It
B
doesn't
A. It
matter. You
doesn't
just
matter.
gave
You
me an
just gave me an
just the
just
reverse
the
of it.
reverse of it.
That's okay.
That's okay.
All right.
All right.
So
So
so this
so
is
this is
Mahi.
Mahi.
This is
This is
Mahi's
Mahi's
preference. All
preference.
right. She
All right.
likes
She likes
D.
D.
I mean C first,
C
then
first,
comes
then comes
B. This is
B.
the
This is
order,
the order,
and we
and
have
we have
Ravina's order
Ravina's order
in this way.
in this way.
All right.
All right.
So this is
So
her
this is her
preference. Okay.
preference. Okay.
Now we are
Now
going
we
to
are
look
going to look
at. We are
at.
going to
We are
come up
going to come up
with
with
profile.
profile.
I mean,
I mean,
we are going to
we are going
compare
to
two
compare two
profiles.
profiles.
It is
It is
profile one
profile one
and profile
and
two.
profile two.
How
How
similar are
similar are
these two
these
people,
two
or
people, or
how
how
dislike? I mean,
dislike? I mean,
how similar
how similar
we are going to check
we are
with?
going to
There
check
is
with.
this
There is
ratio.
this ratio.
How are we going to
How
do
are we
that?
going to do that?
So basically,
So basically,
these
from
kind of
these kind
ordering,
of
just like
ordering,
how we
just like
saw,
how we saw,
right?
right?
So
So
there is a
there is a
smarter way.
smarter
We
way.
just need
We
to
just need
join
to join
these.
these.
Okay,
Okay.
and
So, and
D
D
and
and
E,
E,
right?
right?
Uh,
Uh,
which are all
which
the
are all
things
the
we need
things
to
we
go
need
in
to
the
go
other
in the
way?
other way?
I mean,
I mean,
uh,
uh,
so my
so
question is
my
that
question is that
so
so from
C,
C,
it's in the same
it's in
order.
the
Like
same order. Like
first comes C,
first
then
comes
comes
C, then
C.
comes C.
How do I say
How do
this?
I say
After
this?
you have
After you have
anything that you
anything
can
that
say?
you can say?
Well, so you're saying that since C is like so no, in this case, if you like say for example, take C and D from the first one,
Okay.
then you have
Okay.
CD, whereas in the second one you have DC, right? So that's a flip, no?
Huh.
Huh.
Yeah. So that will count as one inversion, right?
That's right.
That's right.
Hmm.
So here
So
So
if you
here
we
look at
have
we
two
have two
inversions
inversions
basically.
basically.
exactly. So see, in the case of C and D only, if you
Mhm.
see, you have drawn a line from C to C and D to D. Then in the second profile, you can see that there is an intersection there, right? You have this DC and then you have this intersection. So that intersection is indicating that there is a flip. Had it been the case that C would have been the first one, so the original order would have remained, right? CD and CD. Then we would not have gotten that intersection there. So that is the indication of a flip. So that we can count, no?
Yeah.
Yeah.
Yeah, so that we can count, and then that count will basically tell us how dissimilar are these two sequences essentially, right?
Mhm.
So the higher the number of inversions we get, the more
Different
different
they
the
appear.
orderings
Yeah.
are.
Huh.
Yeah, yeah. So then so that is all that I can say.
Afnan, tell me
Afnan, tell me
something.
something like this.
If
So if
the
Yeah.
the
if the
if the
connection goes
connection
in this
goes in
way,
this
like
way, like
this slant,
this slant,
just like what do you
Okay.
call
what
it,
do you call
the
it?
slash,
Just slash,
right? Oh,
right?
this is
Oh, this is
backslash.
backslash.
If it
So
goes
if
in
it goes
Yeah.
in backslash,
that means they
that
are
means they are
not in.
not
There
in.
is no,
There
no
is no
inversion.
inversions.
If it
If
goes
it
like
goes
this,
like this,
it
Hmm.
I think
I think
there is some
there is
inversion.
some
What do you
inversions.
say?
What do you say?
So it
Okay.
is high distance. Does it work?
Does it work?
Yeah, I mean, if we read it in left to right order, in like in English,
Correct.
we also always read it in left to right. So then in
Mhm.
that case, like that backslash or whatever you're calling that, that will be the original thing, right? It is not,
Correct.
opposite.
Hmm.
If it is in the other direction, then it is indicating that, of course, there is some order changes.
Hmm.
So yeah, that also is a good analogy. But then the concept of inversion only comes into the picture when we are considering a pair, no? I mean, independently, we cannot say that, because if you just look at one thing, like just see E and E, then it is not, I think, telling us anything. What do you say?
Hmm. Okay.
Okay.
I mean, that line
Well,
itself
I
is
have
not.
a doubt here.
Yeah.
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 So in this backslash case, there should be at least one inversion, according to me.
What do you mean
What do
by
you
at
mean
least
by at
one
least one
inversion?
inversion?
Because if there would be no inversion, then this backslash line will be vertical. And if it is slanted, then there should be an inversion.
Hmm. Okay. So
Okay.
something
So
like
something like this,
right.
right?
Is this what you're
Is this
saying?
what you're saying?
Hello.
Yes, sir.
Hello.
Okay.
Okay.
So
So
phi.
phi.
How do I
How do
say
I
this?
say this?
Okay.
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 Let's go
Let's
back
go
here
back here
and see
and see.
number of
Number of
inversions is
inversions
four,
is four,
right?
right?
So two
So
three
two
one two
three one
five.
two five.
Yeah. I
Yeah.
mean, two four
Four
two four
two
three
four
one
three
five
one five
and two
and
four
two
three
four
one
three
five.
one five.
So I think
So
the
I
number
think the
of
number of
inversions is
inversions
going to
is
be
going to
the
be
number of
the number of
intersections
intersections
between the
between
pairs,
the pairs,
right?
right?
Afnan?
Afnan?
Yes, exactly.
So
So
that
that
means
means
whatever we did
whatever we
there
did
was
there
wrong.
was wrong.
I mean, it has to be
I mean, it
much
has to
more.
be much
The
more.
previous point that was raised, I think, by Ravina was correct, I think, because see, what happens is that if there is a backslash or whatever you're calling that, right? So
Mhm.
then there has to be something which I mean necessarily intersects with that. Is what I think she was telling us. Is that right?
Yeah.
Yeah, okay, I understand. So whenever we have this four, which is occurring after three, and the other four is occurring after before three in this other
Hmm.
second line.
Yeah.
So what happens is that there is this forward slanting line, forward slash as we call it. So
Hmm.
this forward slash, whenever we have it, then we can say for sure, I think, that there will be at least one intersection for four, right? There is one intersection always
Hmm.
involving four. I mean, it is like necessary, no?
Okay.
Okay.
Because otherwise it would have been a straight line. Of course, that is true, because if four had been would have been at the same place, I mean, like at one, then
Yeah.
it would have been a straight line, and there is no possibility of having an intersection in that case.
Intersection.
Like
Okay.
everything is straight, right? So if
Correct.
everything is like straight line, then it cannot be intersection.
Hmm.
But then since we have a slanting line, then there is a necessity of an inversion happening. But that is only about that general case, right? But then to count them, actually, I think we need to consider pairs only. Because
Hmm.
without checking pairs, I think we cannot count it, right? Because you
Yeah.
have to compare it with something else, right? So you have to have uh, a pair, I mean, at least two components, right?
Hmm.
So yeah, and that intersection is giving us the count, that is for sure. So in this case, we have four such inversions.
Okay.
Okay.
So
So
what does this
what does this
inversion
inversion
mean?
mean?
Gokul, shall I just,
Yeah,
as
please,
Yeah,
far
please.
as
please, please.
my
Yeah.
understanding,
Huh.
actually this 1, 2, 3, 4, 5 is a reference kind of thing. So we are comparing the other set of same thing, but in a different arrangement.
Yeah.
So
Yeah.
one is supposed to come in the front, right? But
Correct.
it has crossed 3.
Hmm.
Hmm.
So there are 3 inversions before 1. That's the kind of meaning you can say.
Okay.
Okay.
3
So
and
So,
2 is supposed to come before 3.
okay,
okay,
before
before
three.
T,
That is
3.
how
That
it
is
is
how it
here,
is
right?
here, right?
Before three,
Before 3,
before four,
before 4,
and before
and
five.
before
Two has
5. 2
come
has come
before three,
before
Yeah,
four,
but
3,
five.
4,
2 is
5.
here 3. So, but 1 is crossing 3 numbers.
Hmm.
Yeah. 3 plus 1, 4. Only 4 has changed the position before 3, right?
Yeah.
Yeah.
Okay.
Okay.
1 also has come after 3 positions. It is supposed to come in the first position. So it is got inversed.
Hmm.
Actually, this idea we are using when we are comparing a set of paragraph.
Okay.
If you
Okay.
come to practical example, that I think that is what it is used for inversions. How many things are inversed, like kind of things like that.
Okay.
Okay.
This is another perception. I, as far as my understanding,
Hmm.
we are comparing a two set of things, which wherever the things are interchanged or inverse, that is counted as an inversion. Like 1 is supposed to come the first position, but it has crossed 3 position, right?
Right.
Correct.
Three.
3
Three.
positions it
Yes.
has crossed. That means that does it
Mean that
mean that
it has
it has
three
3
inversions.
inversions?
I think so. If you count totally, is it coming correct?
So that is
So that is
three. One
3.
is
One
So,
is
three.
having,
Yeah.
yeah,
Front.
Gokul,
front.
one thing, is it possible? Like, could you please draw one case where only one thing is changed, right? So, one element only. I mean, just
Okay.
everything is same. Just one element is now moved. Then I have to see how that intersection is taking place. That I think will give us some clarity on that.
Okay.
So,
Okay.
just one letter will change its position. Everything else will remain the same. Then how the picture looks like. That I think will be an interesting thing to look at. Yeah,
Right.
Right?
Here
exactly,
you can see only one inversion, right?
exactly. So if you draw the lines now,
So the
So
yes.
the
intersection is
intersection
only
is
one
only
point.
1 point.
Yeah.
So there is one intersection only, but taking A alone, right? Taking A alone, what it is telling us that there is one intersection involving A, right? Is
Hmm.
it the right way to look at it? I mean, like as Uma, I think, told.
Yeah, that's what my understanding, because this is applied in such a way we count the same set of paragraph or letters where the letters change its position in the second
Hmm.
set. So that is how we are
But
taking.
then there is, yeah, but then there is another point which I am coming up with is that if one thing has changed, I mean, in this case, only A has changed its position. But given the fact that A has taken a new position, whatever was at that place, initially has also changed. So, I mean, like changes can only be two, right, involving two elements. Because A has not taken the position of B has to move, no, necessarily move, and it has now moved to the position of wherever one A was initially. So there are two changes in that sense. I mean, B has also changed its position in some sense, right? And A also has changed. So, but then pairwise, it is counted as one only.
Hmm.
Hmm.
Hmm. So, if we see A and A, we can say that there is one inversion involving A, and we see B and B, then we can also say that there is one inversion involving B. But both of these things together only count as one, right? So that I think
Okay.
Okay.
is
Okay.
also
Okay.
I can
I
come
can
up with
come up with a,
let's say
let's say
we have
we have
A,
A,
B,
B,
C,
C,
D, E.
D, E.
Right.
Right.
And with
And
A,
with A,
we need to
we need to
compare
compare
B, C,
B,
D,
C, D,
E.
E.
Right.
Right.
So this is the
So this is the
original
original
order.
order.
A, B,
A,
C,
B,
D,
C,
E.
D, E.
Right.
Hmm.
Right.
After A,
After A,
I mean, A should
A
come
should
first,
come
then
first,
B,
then
C, D,
B,
E
C,
should
D, E
come.
should come.
Right.
Exactly.
Right.
Yeah,
Okay.
correct.
Okay.
So,
So,
but
but
B has
B
come
has
before
come
A.
before A.
Mm-hmm.
Right. So,
Right. So
for
for
A, B,
A, B
pair, there is
pair,
one
there is one
inversion.
inversion.
Exactly. Correct.
Right.
Right.
So we
So
saw
we
B
saw
with
B
B.
with
So
B. So
A and A
A
we
and A
cannot
we
be
cannot
compared.
be
That's okay.
compared. That's okay.
So, but
So, but
after A,
after
we have
A, we have
CDE.
CDE.
That is the
Is
same
the
here
same
in this
here in
also,
this
right?
also, right?
After A, we
After
have
A, we have
CDE.
CDE.
After A, we
After
have
A, we have
CDE.
CDE.
Mm.
Right.
Right.
So now we
So
go to
now
the
we go to the
B point.
B point.
Right.
Right.
Okay. But
But
yeah, Uma, you
yeah,
want
Uma, you wanna say something?
No, no, yeah,
okay.
that's how the inversions are, like how it is arranged. Like,
Correct. Correct.
Correct. Correct.
So we
so
go
So
to
if
we go
B.
to
the
B.
order is correct, we don't care. We don't care much. Yeah.
Correct.
Correct.
So we go
So
to
we go
B.
to B.
Right.
Right.
And B
And
we
B,
check
we
with
check with
BB. That's
BB.
okay.
That's okay.
And
And
B is supposed
B
to
is
have
supposed to
A in
have
front.
A in front.
right? B is
right? B
supposed
is
to have
supposed to have
A
Correct.
before it,
Correct.
but we
but
already
we
have
already have
done the pair,
done the
like
pair,
AB
like
is
AB is
inverted, so we don't
inverted,
need
so
to
we don't need
compare
to
B
compare
or
B
B or
and
B
B
or
or
A
B
with
or A
it,
with it,
right?
right?
Again,
So
yeah.
So
Only
after
one.
B
yeah,
is B is
B
followed
is
by
followed by
CDE.
CDE.
That means
That
again
means
here
again
in this
here
pair
in this
also
pair
B is
also B
followed
is
by
followed by
CDE. So
CDE.
that's
So
all,
that's all,
right?
right?
Yeah.
And
And
C
see,
in this
in this
order,
first
the
order,
original
the
order,
original order,
C has
C
AB
has
in front
AB
of
in
it
front
and
of it
DE
and
after
DE
it.
after it.
In
So
this
in this
second order
second
also,
order also,
AB in front
AB
of
in
it,
front of it,
I
and
mean,
be it
A and B,
A
like
and B
two
like
different
two
elements,
different
right?
elements,
They
right?
should be
They
in
should
front
be
of
in front of
C,
C,
and D and
and
E should
D
be
and E should be
after C.
after C.
Yeah.
So that's
So
happening,
that's
and same
happening, and
goes for
same
D
goes
and
for
E.
D and E.
So
So
We can
this is
check with
correct.
the code, in code, no input. We can check it with our own input. We can check
Yeah,
the.
we'll go
we'll
further.
go
Like
further.
we'll just
Like we'll
confirm
just
to this
confirm with
example
this
also.
example
This
also.
one
This
more
one
Yeah.
example
more
we have,
example
right?
we have, right?
Okay. So
Okay.
the
So
original
the
order is
original order is A B
ABCDE,
C D E,
right? So
right?
we'll
So
take
we'll
A,
take A,
right?
right?
So A is
So A
supposed
is
to, I mean,
supposed to, I
all
mean,
the
all
elements
the
should be
elements should be
after A.
after A.
So,
So,
but we have
but we
A
have
and
A
C
and
has been
C has been
interchanged,
interchanged,
correct?
correct?
No, no. A and B is not interchange. Only
A and
C has
C.
come
That's what I'm
That's
before
what
saying.
I'm
A.
A
saying.
and
A and
C.
C.
Yeah, A and C.
A is
A
having
is
an
having an
inversion with
inversion
C,
with C,
Yeah.
right? So this
right?
is
So
in a
this is
different
in a
order.
different order.
So I can
So
write
I
the
can
pair
write the pair
AC pair
AC
is
pair is
inverted,
inverted,
right, Uma?
right,
Yeah.
Uma?
Yeah.
Okay.
Okay.
So
So
then,
then,
okay.
okay.
So then
So
the rest
then
of
the
the
rest
four
of the
elements
four
are
elements are
coming.
coming.
I mean,
I
rest
mean,
of the
rest
three
of the
elements are
three
coming
elements are
after
coming
A.
after
So that
A.
is
So
okay,
that is okay,
right?
right?
No,
No,
B
sir,
is also
BC
B.
BC is also
No, no,
B
no.
inverted.
is also inverse.
I'm just
I'm
talking
just
about
talking
A.
about
I'm
A.
just
I'm
talking
just
about
talking
A.
about A.
Yeah, yeah, yeah.
Okay. Now
Okay.
we go
Now
to
we
B.
go to B.
All right.
All
So
right. So
B should
B
have
should
A in
have
front
A
of
in
it.
front of
In the
it. In
C,
the
the
C,
second
in the
order
second
also,
order
B is
also, B
having
is
A in
having
front
A
of
in
it.
front of
Correct?
it. Correct?
Yes or no?
Yes or no?
And
And
B should
B
have
should have
C after
C
it.
after
So,
it.
but
So, but
we have
we
a
have a
inversion here.
inversion here.
So that
So
means
that means
is
is
inverted,
inverted,
right?
right?
So then
So then
B should have
B should have
D and E
D and
after
E
it. In
after
the
it.
second
In the
order
second
also,
order also,
D and E
D
is
and E
after
is
B.
after B.
Correct?
Correct?
Like,
Like,
am I making
am I
sense
making sense here?
somewhat?
Yeah, yeah.
Somewhat.
I think it is helpful.
Okay.
I'm able to understand it. Yeah, somewhat.
Good.
Good.
Okay. So then
Okay.
we
So
have
then we
C,
have C,
right?
right?
So
So
C
C
should have
should
A and
have
B
A
in
and
front
B
of
in
it.
front of it.
But
But
see,
see,
AC is already
AC is
connected.
already connected.
We
We
have
have
to
put
put
that
A and B
A
are
and B are
inverted with
inverted
C,
with
right?
C, right?
So we don't need
So we
to
don't need
worry
to
about
worry
these two
about these
because
two
these
because
pairs have been
pairs have
already
been already
calculated.
calculated.
But after
But
C, you
after
should
C,
have
you
D
should
and
have
E.
D and E.
And in this
And
case
in this
also,
case
after
also,
C, you
after
have
C, you
D
have
and E.
D and E.
Correct?
Correct?
So basically, what you're doing is you're taking each individual element and comparing that only, right?
Yeah,
Yeah,
comparing
Which
that
all
with
comparing that with
all the other
all
inversions,
the other
elements.
elements.
Yeah.
yeah,
Yeah.
can be
Hmm.
made. How
Hmm.
many inversions can we make using that element? Like
How many
for
How many
A,
inversions?
we can,
inversions have been
yeah.
made?
Huh.
So for example, in this case, for A, we can only have AC and no other thing, right?
Correct.
Correct.
Yeah.
Because
And for
Because
B, we have BC.
huh,
huh.
huh.
So, and
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 not BA.
B,
BA is not there because there is no intersection with B and A.
yeah, that's
yeah,
right.
yeah, that's right.
Yeah, exactly. Okay, understand it. At the time when we are looking at the what is that intersections, we
Mm-hmm.
can also see which all lines are there, right? Like for example, B is intersecting with C, right? There is an intersection there, BC, and
B,
D is
B,
intersect.
which
which
wait, can you
where
tell
can
me?
you tell me?
Like,
Like,
Yeah, in this first one there is B, no
mm-hmm.
hmm.
Okay, the B
Okay,
line,
the B line, the line
B and
connecting
B
B
and
and B
C
and
and C
C
has
and
an
C has an
intersection,
intersection,
which means
intersection. So we
which
B
can
and
means
say
C
that
B
are
and C.
BC is an
inversion.
inversion.
Okay,
Yeah,
Okay,
exactly. So that way we can make up all the pairs.
correct.
Yeah,
correct.
even on that number line, it's like that. One is intersecting with everything. That is why we get the dot and the one line, one pair.
Huh.
Huh.
If you see the intersection is happening because of the one line, also with the fourth line.
Also with the
Also
fourth
with the
line.
fourth line.
Hmm.
Yeah,
Okay,
Okay,
because four is
because four
Apart
supposed
is
to.
from
supposed to.
five, I think one
Uh-huh.
is intersecting with everything else.
yeah, because the one is the one which is completely reverse, right? The order is reversed. We are
Mhm.
counting the other three elements.
Okay.
Okay,
Correct, correct. So that also gives us the count for that individual element, like for
Hmm.
one only.
Hmm.
There are three such inversions.
Yeah.
yeah,
Okay.
Understood.
okay.
So hope
So
it
hope
was
it
little bit
was
clear.
little
I
bit
think.
clear. I
Mahi,
think
you have
Mahi,
any
you have
doubt
any
now?
doubt now?
Did you
Did
understand?
you understand?
Can we complete what we are doing? Like,
That is what we
That
are
is what
trying
we
to
are
do.
trying to do.
Okay, you
Okay,
you don't have
you
any
no,
don't have
doubt now,
any
but
doubt now, but you want to see
it
if
is
it
complete.
is complete.
After completing,
After
you
completing,
want
no,
to
you
tell.
no.
want to tell.
Huh.
I am saying, can we complete the thing? Yeah.
Whichever this
Whichever
one.
We are
this one.
at C now. We are at C. How we are? How we did for C?
Yeah, you
Yeah,
tell now.
you tell now.
Now we
Now
did
we
Yeah.
came to
C.
see.
Yeah, it's C. D and E is at the front, and and in the next line as well.
Sure.
But
No, no, no.
No, no,
So
no.
for
A
So
and
for
B is
A and
A
B should
and B
be
should be
A
like
and B
A
have
and B
already
has
been
already been
inverted, right?
inverted,
We
right?
can see
We
that.
can see that.
Hello.
yeah.
Hello.
So
So
tell me.
AC and AC should be there.
Yeah, it's
Yeah,
already
it's
here,
already
right?
here, right?
As
As
inversion.
inversion.
Mm-hmm.
Mhm.
Okay, okay, okay.
And
Yeah.
And
BC is
BC
also
is
there,
also there,
right?
right?
BCCB, that
BCCB,
doesn't
that
matter.
doesn't
All
matter.
right,
All
that
right,
pair
that pair
basically.
basically.
Okay,
Okay.
and then
Okay,
And
okay.
then
so that
so
means
that means
C should,
C should,
so that
so that
inversion is done.
inversion is done.
After C, you
After
should
C,
have
you should
D and
have
E.
D and E.
That's how it
That's
is
how
here
it is
also,
here
right?
also, right?
After C,
After
you
C,
have D
you
and
have
E
D and E
or E and
or
D.
E and D.
That's okay, right?
That's okay, right?
Mahi?
Mahi?
Yeah.
Very good.
Very good.
So
So
Now we take
now
yeah,
we
D
take
point.
D point.
yeah.
Okay,
Okay.
so in the
So in the
original
original
order,
order,
D should
D
be
should be
after
after
ABC,
ABC.
correct?
Correct?
Yeah.
D should be
Should
after
be after
ABC. So
ABC.
in the
So in the
second order
second
also,
order
is
also,
D
is
after
D after
ABC?
ABC?
No.
Yes.
Yes.
A,
A,
B,
B,
Yeah.
C, and we
Yeah.
have
and
D
we have
here.
D
Right?
here.
D
Right.
is
D
after
is after
ABC.
ABC.
So
So
this is okay.
this is okay.
So that is
So
fine.
that is fine.
So
So
so D should
D
be
should be
before E.
before E.
Is it the
Is it
same
the
in this
same in
order,
this
in this
order, in this
second list?
second list?
No, right?
No, right?
So DE should
So
So
D, E
D,
should be
E
there,
should be there,
right?
right?
be.
And
And
for
And
we have
E,
for
three
E,
intersections.
and we have
and we
three
have three
inversions or
inversions or
intersections, you can say.
intersections, you can say.
Inversion. Okay.
Yeah,
Yeah,
good.
good.
So that's
So
all this
that's all this
concept is all
concept is
about.
all about.
Hope it
Hope
was
it
we
was
were able
we
to
were able
clear a
to
little
clear a
bit.
little bit.
Um,
Um,
hmm,
hmm.
okay.
Okay.
So Uma,
So
shall we
Uma,
go
shall we
to
go
this
to
now?
this now?
Like, shall we
Like,
look
shall
into
we
the
look into
course
the
how it
course,
is
how it
working?
is working?
Yeah, in this we can give our own input and check, right?
Huh.
Huh.
All right.
All right.
So who would
So
like
who
to
would
help
like
me
to
out
help
here?
me out here?
Vicky, are you
Vicky,
here?
are you here?
Vicky.
Vicky.
Yes, sir.
All right.
All right.
So did you
So
listen
did you
what was the
listen what was
inversion
the
and
inversion
everything?
and everything?
Yes, sir. I have listened inversion. So basically, sir,
Mhm.
can you again explain me when I have to find inversion? Just we have to see like crossing edges.
Correct.
Correct.
You just draw
You just
lines
draw
A,
lines
B,
A and
B,
A,
B,
B by B,
like
like
the C,
the
C,
C,
D,
C,
C,
D, D,
E,
E.
right?
All right.
Okay.
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 So wherever
So
there is
wherever
an
there is an
intersection,
intersection, you
you
just
circle it.
circle it.
That's
So
my
that's
number of
my number of
you have.
inversions you have. Simple.
Okay.
All right.
All right.
So
So,
so if you
so
take
if you take
so
this,
the
so
original
the
order,
original order they have by default put it like
one, two, three,
1, 2, 3, 4, 5. All right.
Vicky.
Okay.
Yes, sir. Yes, sir.
Okay.
Okay.
So the
So
second
the
list we
second
have.
list we have something. All right.
So that is what
So
the
that is
input
what the
is.
input is.
So looking
So
at this,
looking at
you
this,
just
you just
2, 2,
2,
3,
2,
3,
3, 3, 1, 1.
you're just
You're just
drawing lines,
drawing lines,
joining the
joining
two,
the two
right?
orders. All right.
So how
So
many
how many
intersections does it
intersections
have?
does it have?
So that's the
So
number
that's
of
the number of
inversions. Got it?
inversions. Got it?
Okay.
But how do you
But
And
how
one
do
thing
you
also,
find it?
tell me?
Tell me.
sorry, sir, what is the use of this? Like when we find like four inversions, so what I can use this?
Okay.
Okay.
So it is like
So it is
how
like how
similar are
similar
your
are your
liking and my
liking and
liking.
my
So you
liking. So
watch a
you watch
YouTube
a
channel.
YouTube channel.
I watch a
I
YouTube
watch a
channel.
YouTube channel.
Like how
Like
similar
how
the
similar
Okay.
the
videos are coming
videos
up.
are coming up.
Right. For
Okay.
For
example, we have
example,
taken
you have taken
PDSA. I also
PDSA.
have
I
taken
also have taken
PDSA.
PDSA.
We'll be
We'll be
watching
watching
the same
the
lecture.
same lecture.
That means there is
That
some
means there is some
similarity.
similarity.
If you like a
If you
lecture,
like a
you
lecture,
give a
you
thumbs
give
up.
a
I
thumbs
also
up. I
give a
also
thumbs
like
up.
a thumbs up.
Right? How many
Right? How
minutes
many
you watch
minutes
the
you watch
lecture?
the lecture?
That's also
That's
there, right?
also there, right?
So
So
Okay.
it's
it's
gonna
gonna
compare the
compare the
similarity and it's
similarity
gonna
and
give
it's
a
gonna give a
recommendation for you.
recommendation for you.
Okay, your
Okay,
products
your
will be
products will be
recommended to me and my
recommended to me,
products
and
will
my
be
products will
recommended
be
to you.
recommended to
Like,
you.
right,
Like,
Uma?
right, Uma?
Am I right?
Am I right?
Yeah, yeah. In the YouTube, we are getting that our whatever we like, the videos are coming to us, no?
Mm-hmm.
According to our taste. I think that's what they said. That
That's right.
application,
That's right.
these
That's
kind
right.
of things are applied. I think.
Hmm.
Hmm.
So those
So
kind of
those kind of
this is what you
that
will
is
learn
what
in
you will
machine
learn in
learning and
machine learning and
foundations engine.
foundations and
Recommendation engine,
recommendation
how it
engine,
works,
how it works,
right?
right?
Yes.
Sure. So that's
So
the use
that's
case
the
for
use
this,
case for
right?
this, right?
So coming
So
back
coming back
here to the
here
code,
to the code,
right? The code
right? The code
starts from
starts
this
from
line.
this line.
Okay,
Okay,
you
so
have
you
your
have
own
your
order.
own order.
We have the
We have
original
the
order,
original order,
but
but
here is one
here
order.
is one order.
This is the input
This is the
order we are
input
giving.
order we are giving,
And what is
and what
happening?
is happening?
What does this
What does
mean
this mean
of
of
one,
one?
guys?
So yeah,
Guys?
Huh?
may I add something here?
Yeah, please.
Yeah. So what happens is that in this merge and count method, you can see that we are returning a tuple, right? So in this first component of that tuple is C. So C is a list, right? So this I think it's a, sorted list or somewhat similar to that. And the second component is actually the count. That is why we are taking, inversion count, whatever it returns, the return of that, and then we are taking first of one of that.
No,
of 1. That
let's check
yeah,
that.
Hmm?
that gives us the count actually. You can see that this return statement in line number 22, we have C comma count, right? So to
Oh,
get
okay.
the
Oh, okay.
count, we are getting that
Hmm.
1 there
Okay.
because
Okay.
C is the list. Yeah, we need the count, no? Yeah.
Yeah, that's right.
Yeah,
Number
that's
of
right. Number of
inversions
inversions
we
we
have
have basically.
hmm
basically. So, let me see. It's running.
Running
Seems like
seems like
so. It's gonna
so it's going
compare
to compare
everything with
everything with
everything, right?
everything,
It's
right?
gonna
So
take
it's going
some
to take
time, I
some
think.
time, I
Right?
think, right?
It will take some
It will
time.
take some time.
Mhm. Yeah, that's
Yeah,
done.
that's done.
So we have
So
4.
we have
So,
4.
so we shall
We
print
shall print
inversion count and
inversion
see,
count
right?
and see, right? Um,
What do I need
how
to
do I
do
need
this?
to
Let's do this.
do this?
If I do this,
If I
it
do
will
this,
come,
it
right?
will come, right?
Both will come.
Both will come.
Yeah.
Yeah.
So probably
So
they are
probably
giving
they
the
are giving
original
the
list
original
and
list and
the number of
the number of
inversions.
inversions.
Okay.
Okay.
Yeah.
Yeah.
No, I think this one is the sorted version of that original list, whatever we give
Uh-huh.
as the input. Yeah, you can see that this is 1, 2, 3, 4, 5 now.
Correct. Correct.
Correct. Correct.
Whereas the original list was something else, 2, 3,
Mhm.
2, 4, 3, somewhat like that.
Basically, these
Basically,
are
these are
One.
rankings, right?
rankings,
Yeah.
I
right?
rank this is the
This
rank
is the
one,
rank
rank
one,
two, rank
rank two,
three,
rank three.
something like
So
that.
I think as a consequence of that merging process that we've
Mhm.
gone through, that list gets automatically sorted is what I believe, right? That merging is kind of implicitly happening. The merge actually is the same merge that we get that we have in the merge sort algorithm also. So merge is same, slight modification is there. In fact, this count only has been added. Everything else is same, I think.
Yeah,
Yeah,
That was
let's
also
go and see the code now. Let's go and
yeah,
explore the code.
what do you say?
What do you
So
say?
exactly.
our comparison is with the sorted list, right? Not with the input with the sorted input, I think, right? That's how we get the inversion because we need a reference to get the inversion, right?
Mm.
Mm.
So
Yeah, that
we are
is
doing
correct.
only
Actually,
pointing, right?
that's
Yeah,
what
that's
Uma.
what
That's what
Uma. That's
Uma.
what Uma.
So you have
So you
ranked
have
in
ranked
a
in
different
a
way, right?
different way.
So
Like
this is
so,
what.
this is what.
Oh, okay, kind of ranking. We can take it as a
Uh,
ranking.
Uh,
Okay.
yeah.
So
yeah.
how it is ranked?
So
Okay.
you
So
rank the
you rank
second
the
one
second
as the
one as the
like
like
I mean,
second.
Okay,
someone else's
okay,
second
got
rank
it.
is
Second
your
rank is
first
your
Yeah,
rank.
first rank.
yeah.
All right.
All right.
Yeah.
Yeah.
So we give
So
the
we give
input
the input
and we call
and
the
we call
inversion
the
count
inversion count
function and we
function
take the
and we take
input.
the input.
This is the
This is
length
the
of
length
the
of the
n is nothing
n
but
is
the
nothing
length of
but the length of
a.
a.
Okay, if
Okay, if
n is less
n
than
is
or
less than
equal
or
to
equal
one,
to
that's
1,
that's okay.
that's okay.
That's the
That's the
recursion
in
ending of the
ending of
recursion,
the
right?
recursion, right?
Stop condition
Stop
for
condition for
recursion.
recursion.
Okay.
Okay.
So
I'm not
So
getting it. Is it written a comma 0?
that
that means
Oh,
means
count,
when
count.
when n is
when
Okay.
n
equal
is
to
equal
one,
to 1,
wait,
right?
Yeah,
when you have
When
count.
you
only
have
one
only
list, there
one
is
list,
no
there is no
inversion,
inversion,
Okay.
basically.
basically.
Yeah.
Yeah.
So
So
let's come back
let's come
here.
back
So
here.
what is
So
this?
what is this?
L
L
count
count
L
L
comma count
comma
of
count
L
of L
equals
equals
inversion count
inversion
of.
count of.
Okay, what's
Okay, what's
happening?
happening?
So shall we
So
take
shall
this
we
to
take this
paint?
to paint?
All these are
Or these are
recursions.
recursions?
Hmm. Okay.
Okay.
So
So
I'm putting the
I'm putting the
IC of
IC of
A.
A.
All right.
Right.
So this
So
is
this
actually
is
calling
actually calling
um
um
L
L
Can you
comma.
zoom
comma.
little bit?
Yeah, sure.
Is
Is it okay?
it okay?
I mean, you
I
want the
mean, you
code
want
to
the
be
code
zoomed
to be
up.
zoomed up.
Slightly.
Okay, and then I'll
Then
zoom it
I'll
here and
zoom
then
it here
take a
and then take
screenshot.
a screenshot.
Works.
Works.
Yeah.
Great. I'll just select these. I don't need these. Yeah, coming back here. So
So
first we call
first
the
we call the
inversion count of
inversion
the
count of
original
the
list,
original list,
right?
right?
So that is
So that is
actually what is
actually
it
what
doing
is it
is
doing? It is
actually
actually
dividing the list,
dividing the list,
I think.
I think.
So L
So L
and
and
LC. I'm
LC.
gonna put
I'm gonna put
CL.
CL.
How do I do? Yeah, Uma.
Yeah, Uma.
So in this
So in
line,
this line,
we are
we are
actually
actually
dividing the list
dividing the
into
list
this is
into
this
this
right
is
off.
right
I
off.
mean,
I
right
mean,
off or
right
left
off
off?
or left off?
Left, right? Up
Very
to
good.
n by 2.
Correct.
Yeah.
Correct.
So L
So
comma
L comma
CL.
CL.
Right.
Right.
So this
So this
the
the
first list
first list
you're calling the
you're
same
calling the
IC
same IC.
inversion count
Inversion
of
count of
uh,
uh,
left.
left.
Okay.
Okay.
For
For
R
R,
CR,
CR,
we're gonna call the
we're gonna call the
inversion count of
inversion count of
right list.
right list.
Correct. That's how
Correct. That's how
that is what is
that is
happening,
what is
right?
happening, right?
Yeah, but that is a recursion call, no?
It'll keep
It
on
will keep on
reducing.
reducing.
Yeah, so until one element, I think, right?
Until one
Until
element
one
is there,
element
it
is
will
there,
keep
it
on
will keep on
doing it,
doing it.
right?
Right?
So let's
So
see, let's see.
let's
So
see.
we
So
have the
we
list:
have the list
2,
2,
4,
4,
3, 1,
3,
5.
1, 5.
Okay.
Okay.
So
So
initially,
initially,
how do we take
how
it?
do we
Like
take it? Like
n double bar
n double
2.
bar
How will
2.
it
How will
split?
it split?
Here,
Here,
5 double
5
bar
double bar
4 is
4
basically.
is
I think it will
basically. I
split
think it
like
will
this,
split
right?
like this, right?
Yeah, 2 4.
Yeah.
Yeah, correct.
So and this we
And
are gonna
this we are
split
gonna
into
split into
two list,
two list,
right?
right?
2, 4,
2, 4,
and
and
this is
this
going to
is
be
going to
split
be
into
split into
3,
3,
and this is going to be
and this is
1
going to be
comma
1
5.
comma
Am I
5.
right?
Am I right?
Yeah.
1,
1,
5.
5.
Similar to the
Similar
merge
to the
sort is
merge
what
sort
is
is what is
happening.
happening.
So there
So
we
there
go.
we go.
So
So
after, okay,
after, okay,
at this
at
point,
this
right?
point, right?
So
So
Uma,
Uma,
if
if
n is less
n
than
is
or
less
equal
than
to
or equal
1,
to 1,
right?
right?
So n
So
is
n
equal
is
to 1.
equal to
So
1.
this is
So
going to
this is
return
going to
what?
return what?
A comma
A comma
0.
0.
So this is
So
going
this
to
is going to
return
return
inversion count as
inversion
0,
count as 0,
right?
Yeah.
right?
Uh, and
And
it is going to
it
be
is going
like
to be
A
like
is
A
nothing
is
but
nothing but
2
2,
comma
comma
0.
0.
This is what it
This
is
is
going
what
to
it is
return,
going to return,
right?
right?
And this is going
And
to
this is
return
going to return
the list
the list
4
4,
comma
comma
0.
0.
Okay,
Okay.
and
And
so that's
so
okay.
that's
So
okay. So
these two are
these
being
two are
returned.
being returned.
So B,
So
we have
B, we
something
have
called as
something
B,
called as B,
merge and count.
merge and
We should
count.
call
We
this
should call
function, I
this
think,
function, I
right?
think, right?
B comma
B, comma
CB equal
CB
to
equal to
merge count
merge
of
count of
left comma
left, comma
right.
right.
So left is
So left
nothing
is
but
nothing but
the list
the
2
list 2
here, right?
here, right?
Yeah. 2 and
And
4 will be merged.
correct.
Correct.
So
So
we'll see
we'll
merge
see
and count
merge
of
and count
2,
of
1,
2,
4.
1, 4.
We'll see that
We'll see that
code.
code.
Okay.
Okay.
So
So
M and
M
N.
and
Okay, I
N.
think
Okay, I think
this is the
this is
same
the
code.
same code.
Yeah, but slightly different. Like Afnan said, the count only is added extra.
Okay, let's
Okay,
see this.
let's see
Right.
this. All right, still.
My, are you able
My,
to
are you
follow a
able to
little bit?
follow a little bit?
Like if you
Like
have
if
any
you
doubt,
have any
please
doubt,
stop
please
then and
stop
there. Like
then and
just
there, like
how we
just
used
how
to
we
do.
used to do.
Okay,
Okay,
Ravina.
Ravina.
Yeah, okay.
Yeah.
Yeah.
Okay.
Okay.
So where are we?
So where are we?
We have M
We
and
have
N,
M and N,
right?
right?
Length of A
Length
and
of
length
A
of
and
B. In
length
this
of B.
case,
In this
it's
case,
just
it's
one
just
one,
1, 1,
right?
right?
Uma?
Come on.
See, right, Uma?
See, right, Uma?
2, 4. Okay. Yeah, yeah.
Yeah, we're
Yeah,
just taking
we're
two
just
comma
taking
4,
2,
right?
4, right?
Yeah, yeah. True.
2 and 4. The
2 and
length is
4. The
going to
length is
be
going to be
that.
that.
All right.
All right.
So these are
So these
nothing
are
but
nothing but
the
the
initialization.
initialization.
I, J,
I,
K,
J,
count,
K, count,
C.
C.
That's okay.
That's okay.
C is going to
C
be
is going to be
the
the
final list.
final list.
Just like
Just like
Afnan told,
Afnan told,
we
like
are going to
we are
get
going
a
to get
merge
a
list,
merge list,
like
like
sorted list.
sorted list.
Yeah, sorted version of that. Yeah.
Great.
Great.
So that means
So that
Because
Hmm.
always I think by convention that sorted version of the ranking is what we take as the canonical version of that reference point. Yeah.
Okay.
Okay.
So by the process we are checking whichever is minimum, and whenever that flip happens,
Mhm.
we are adding that to count, so that in line number 21 that is something that is happening, right? So wherever we have how to put it, right? So wherever we have essentially uh, as we I think explored in the visualization also, that whenever we have something which is before something which should have been uh,
Yeah,
coming
Yeah.
earlier,
correct.
then we
Correct.
add the count. Something similar to that is
Okay.
happening here also. But anyway,
Let's
carry on.
let's see.
Yeah.
Let's
Yeah,
see.
Yeah.
Yeah.
Okay. All right.
let's see how
See
the
how the
inversions are
inversions are
happening for
happening
this
for
case.
this
All
case.
right.
All right.
So
So Uma,
coming
back
back here,
here,
right?
right?
While K
While
is
K
less
is less
than,
than,
so
so
what is
so
this
what is
actually
this
checking?
actually checking?
K is going
K
to
is
be
going to
0,
be
right?
0, right?
0 is
0
less
is less
than or
than
equal
or
to
equal
what
to
is n
what is
plus
M
n? It
plus
is
N?
2.
It is 2.
Yeah.
So that's the
So
while
that's
loop.
the while loop.
So that means
So
the
that
loop
means the
is going
loop
to
is
run
going to
for
run for
0,
0,
1, 2.
1, 2.
3
3
iterations will run.
iterations will run.
Yeah.
Probably if we don't
Probably
have
if
a
we don't
written
have a written,
break
break
statement.
statement.
Okay.
Okay.
So what is
So what
happening
is
here in
happening
this
here in
line?
this
If
line? If
I
It
I,
is, yeah, it is 0, right? Both are 0, I think. M is 0, I is 0. Sorry, M is 1.
uh,
uh,
M is 1
M is 1
exactly.
exactly.
So this
So
Yeah.
condition
this
is not
condition is not
satisfied.
satisfied.
Yeah.
Right. We don't need
Right?
to
We
go
don't
to
need to
this
go to
line.
this line.
So we'll go to
So we'll
LF,
go to LF,
right?
That is
right?
also not true.
That is also
That is
not
also
satisfied
not
because J
satisfied
is
because J
0
is
and
0 and
N is
N is
1.
1.
Right.
Right?
So we go
So
to
we
the
go to the
Yeah.
LF.
LF.
A of
A of
I.
I.
So A of
So
I
A
is
of I
2.
is 2.
B of I
B of
is
I
3.
is 3.
Yeah, the
Sorry,
condition
not
is
So
3,
not
it's 4.
3, it's
I'm
4.
sorry.
I'm
2
sorry.
and 4.
Yeah,
So we compare
correct.
Correct.
and we
So,
append 2 to the list. C.
So we
So we
compare it.
compare it.
So we
We
append
append
2 comma
2
4 to
comma
the
4 to the
wait.
wait.
Are we
Are we
okay? Wait.
okay? Wait.
2 is 2 is what
2
we
is
are
what we
appending
are
to the
appending
list,
to the list,
right?
right?
Yeah, yeah.
Okay, we append
We
2 to
append
the
2
list,
to the list,
and
and
I plus
I plus
K.
uh,
the value of
the
I
value of
and
I
k is
and
being
k is being
increased.
increased.
So value of
So value of
I is
I is
basically
basically
nothing
nothing
which
which
is
is
representing
representing
ek uh,
uh,
the
the
pointer,
pointer,
Pointer, yeah.
the pointer
the
of A
pointer of
list,
A list,
and k
and
is going
k
to be
is
the
going to be the
some
some
how many
how
elements we
many
have
elements
passed
you
in
have passed in
past basically.
past
Iteration,
basically.
right? Rating iteration.
So we can
So
say
we can
that's
say
right.
that's right.
Okay,
Okay.
so
So
else,
else,
but it's
but
not else
it's
case
not else
right
case
now.
right
Now
now.
that is
Now
done.
that is done.
The first
Yeah.
The first
iteration is done.
iteration is done.
So we have
So
put
we have put,
sorry.
sorry.
Coming to the second iteration, right?
Yeah, coming
Yeah,
to the
coming
second
to the
iteration.
second iteration.
So we have
So we
put
have put
C into
C
the,
into the,
2 into the
two
C
into the
list,
C list,
right?
right?
And the
And
value
the
of,
value of,
let me not put
let me
it
not
there.
put it there.
Okay,
Okay.
C equals
C equals
2 now,
2 now,
right?
right?
Sorry, one step down. And we have
And
I
we have I
equals,
equals,
now the
now
value of
the
I
One.
is
value of I
1.
is 1,
M is also one, right? So you will enter with
Hmm. Not M,
not
it's K
M, it's
equal to
K
1,
equal to 1,
right?
right?
yeah.
Hmm.
Hmm.
For
Okay.
the if
Okay.
loop.
Huh.
Huh.
So now we
So
go
now
come
we
to the
go
next
come to the next
iteration.
iteration.
The if loop
The
is
if loop
going
is
on,
going on,
right?
right?
If I
If
equal
I
to equal
equal
to
to
M,
equal to M,
I is
I
also 1,
is 1,
and M is
and
also
M is
1.
also 1.
So
So
we are at the
we are at the
end of the
end of the
eighth list.
eighth list.
So this
So
list is
this
getting
list is
directly
getting
appended
directly
there,
appended
I
there,
think,
I
right?
think, right?
Yeah.
All the
All
elements
the elements
will probably
will
be
probably
appended.
be appended.
Okay, so
Okay.
C
So C
instead of C we
instead
are
of C we
appending
are appending
4,
4,
right?
right?
So J
So
plus
J
equal
plus
to
equal
1
to 1,
and K plus
and K
equal to
plus
1.
equal to 1.
So that's
So
okay.
that's okay.
Basically, the
Basically, this
citation is
citation
gonna
is
end
gonna
now.
end now.
So K
Yes,
equals,
K
that's
equals,
simple. So when I is equal to M is satisfied, because given the fact that this is equal to the length, right? So then
Mhm.
that will be over. Given the fact, I mean, so for 2 it will not run basically, because see what happens is that this while loop is checking for while k less than, which
Acha.
is not
Acha.
equal to, right?
Okay, okay.
Just
Okay,
less
okay.
than, so that it means that M plus N, when it is going to be equal to that length, whatever that is,
Mhm.
then before that only it will run. For 2 it will not run. So 0 and 1 only. Yeah.
Okay.
Okay.
So that means
So
in
that
this
means in
case,
this case,
that's all right.
that's all right.
So that
So
means
that means
0 and 1
0 and
Yeah.
only,
1 only,
Probably
which
that
is
is
done.
over now.
1.
Yeah.
Yeah, that is
Yeah, that
over.
is over.
And we have
And we have 2
2,4 in
comma
the
4
list.
in the list.
And the
And
inversion
the
count is
inversion count is
basically
basically
0,
nothing.
right?
0, right?
We still did
We
not
still
come to
did
this
not come
part.
to this part.
Yeah, because 2 comma 4 was the original input as well, I think.
Huh.
Huh.
Not, yeah,
Mm,
Not,
that's
that
right.
yeah,
is,
But
that's right.
basically,
Basically,
what it
what
refers
it
yeah.
to,
refers to,
I'm coming
I'm
to a
coming
point.
to a
So
point.
the
So the
original list,
original list is,
how was it?
how was
1,
it?
2,
1, 2,
like, let me take x equal
x
to
equal to
1, 2,
1, 2,
3, 4,
3,
5,
4, 5,
right?
right?
So, and if
So,
you are
and if
given
you are
a
given
length,
a list,
okay,
okay,
y equal
y
to
equal to
2 comma
2
4.
comma 4.
Let's see.
Let's see.
Uh,
Uh,
2,
2,
4 should come
4 should
after
come
2.
after 2.
I mean,
I mean,
right?
all
That's
right?
what is
That's what
happening
is
here.
happening here.
Yes or no?
Yeah.
Yes or no?
We don't have
We
any.
don't have any.
We don't have.
We don't
We
have.
just try
We
to
just try to
join lines
join
for
lines
these
for
two
these
things,
two
and
things,
we don't have
and
any
we don't have any
intersection.
intersection.
So
So
Yes.
now this is make
now
kind
this
of
is make
making
kind
some
of
sense,
making
right?
some sense, right?
Yeah.
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 So
So
others,
others,
Mahi,
Mahi,
like, is it
like,
making
is it
sense?
making sense?
Oh my God.
Oh my God.
Hello,
Hello,
uh, Anshul,
Anshul,
Vicky,
Vicky,
are you able to
are you
see?
able to see?
Yeah. You
Yeah.
have any
You have
doubt?
any doubt?
Yes, sir. Sir, can you repeat the line 2 comma 4 upper portion? Like scroll down. No, up. Sorry, up. Scroll up. You have taken the example. I couldn't understand why you taken y equal to 2 comma 4.
Because
Because
you remember
you remember
we have
we have
split this and we
split
are
this, and
trying
we
to
are trying
merge
to
these
merge
two.
these two.
Okay.
So when we
So
merge
when we
these
merge
two,
these two,
we get
we get
a list
a
which
list
is 2
which
and
is
4.
2 and 4.
We get a
We
Okay.
get
list
a list
which is
which is
together
together
as 2
as
comma
2
4.
comma
Okay.
4. Okay.
So
So just
imagine
imagine
what is
what
happening?
is happening.
1, 2,
1, 2,
3, 4,
3,
5. This
4,
is the
5. This is the
original list,
original list,
right?
right?
And we have
And we have
2
Yes.
and 4
2 and
here.
4 here.
So now
So now
try to
try to
draw
draw
lines.
lines.
Is there
Is
any
there any
merging?
merging?
Is there
Is
any
there any
No.
intersection?
intersection?
No. So
No.
that
No.
means the
So
No.
that means
inversion
the
count is
inversion
0.
count
That
is
is
0.
what we
That
are
is what
getting
we are
here.
getting here.
Oh, okay.
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 Now,
Now,
similarly,
similarly,
the same thing is going
same
to
thing is
happen
going to
there.
happen there.
So we
So
have
we have
1 and
1
5.
and 5.
I think for
I
1
think
and
for
5
1
also
and
we
5
won't
also
have
we
the
won't
same.
have the
We
same.
won't
We
have
won't
any
have
inversion,
any
right?
inversion, right?
Uma?
Uma?
Yes.
Yes, yeah.
Very good.
Very
So
good.
one and
So one
five
and five
also we don't
also
have
we
any
don't have
inversion.
any inversion.
So
So
these two
these
lists
two
are
lists are
combined together.
combined
Now
together. Now
let me
now
just
let me just
erase the.
Excuse me,
Yeah,
one
yeah,
question.
yeah,
Can we just keep it? Yeah. So 1, 2, 3, 4, 5, that list that you've given, right?
yeah.
And we're comparing 2 and 4, right? So in the case of a split, I believe it'll not be the case, right? I mean, in this case, right? See, you see, we have this list 2, 4, 3, 1, 5, and then we are only splitting on that, so we're getting 2, 4, and then we are combining that, so we get 2, 4 back, which
Mhm.
was the original list 2, 4 in that sub problem.
Correct.
But in this case, the example that you have taken 1, 2, 3, 4, 5, and
That's
then
the
you are
original.
comparing 2 and 4. I think it cannot skip, right? It cannot skip in between. But I'm not sure. I just wanted to ask, like, how are you taking 2 and 4? Like, there is three in between, right? I
No, no.
think the
After he's telling, as of now, at the
hmm,
present, we are returning back 2 and 4. Whatever the recursion happened, this is the first recursion call, which is returning 2 and 4, right? Of now, in that count
yes.
is zero. So Gokul
Hmm.
is telling why count is zero, because two
Okay.
and four in the original list is same.
Okay.
That
Okay.
is why we are getting the count as zero.
Exactly. That is correct.
That
So
is
my
what he's
question is,
explaining. Yeah.
yeah, that is correct. But my question is something else. My question is that 1, 2, 3, 4, 5, is it the original list, or 2, 4, 3, 1, 5, is it the original list? I think 2, 4, 3, 1, 5 is the original list and not 1, 2, 3, 4, 5.
No, but the reference is, that's what I asked, right? How we are comparing
Acha.
two, four,
Okay,
three,
okay,
one, five.
okay. That
The reference
reference.
is always a sorted
Hmm.
one, right? So
Exactly.
that is
So
what
we
we
are
are comparing.
checking it
Yeah.
with the reference. Hmm.
Yeah. This our input we are giving is checked with the sorted one, and
Hmm.
that's how we are getting the count.
Okay. It is clear now. I thought in the recursion itself, because in the
Yeah,
recursion,
I had a
see,
doubt. That's what I asked. Where
yeah.
why we are comparing this thing? That's why Gokul told it is a ranking. So ranking is always 1, 2, 3, 4, 5, right?
Mhm.
So, but
No,
I give
yeah,
a different opinion.
that is correct. I think that is correct. But my thought process was also going into that fact that whenever we are splitting, so in this case, you can see that 2, 4 is one small list that we have now. Now, whenever we do the merge on that, then 2, 4 only becomes the reference point for this particular process. This for this merge, the reference point I think will be 2, 4 only, and not the original list, is what I believe.
Yeah, even then it's the same, right, as input.
Yeah, it will be the same, but then I think in this case 2, 4 only is the reference point, is I think I
Yeah, yeah. But okay, but when you
yeah,
compare the input, the 2, 4 is the same.
yeah, that
But
is also same, and
it
it has to
cross.
it has to
Sorted.
match.
Yeah.
It has to match. Yeah, okay, that
So
is
you
correct.
are
But then
confused about
yeah,
that. Yeah,
because if
maybe
we
you're
hmm,
confused about 1, 2, 3, 4, 5. Okay.
because
Yeah.
if we print that list, whichever list we are merging,
Yeah.
whichever we are getting after the merge, that will be 2, 4 only, and not one the original one.
Yeah.
that that is true, that it will be matching with the original one. That
Yeah.
is why we are not counting any inversion, so that is totally fine. But then as for recursion, I think that small list is the only the reference point, and not, because at that point yeah, because at that point the program doesn't know about the original one, right?
Yeah.
That particular, what it is called a stack
Yeah.
frame,
But
right?
since it is on the left, you will not definitely get that inversion, I think, right?
Exactly,
The
exactly.
same thing. Yeah.
Hmm. But it is okay, it is clear to me now. Thank you.
All right.
All right.
So
So
we shall
we
go
shall go
further.
further.
Right.
Right.
So that
So
means
that
we
means
have
we
merged
have
this two
merged
and
this
four
two and four
together,
together,
right?
right?
So
So
it is
it is
clearly
clearly
visible that
visible that
for
for
the
the
list 2
list
comma
2
4,
comma 4,
the
the
inversion is
inversion
zero.
is 0.
Total number of
Total number of
inversions is zero,
inversions is 0,
right?
right?
When we try
When
to
we try
merge
to
this,
merge
now
this,
shall we
now
take
shall we
these as
take these
input?
as input?
Uma?
Uma?
Hello.
Hello?
Yeah.
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 And
So
there
now,
So
is
now,
yeah. So
yeah.
1 and
So
5
1
also
and
there
5
is
also there is
no
no
inversion, right? It
inversions,
is
right?
going to
It
be
is going
zero,
to be 0 only,
yeah.
right?
right?
So
So
now we are trying
now we
to
are trying to
merge these two,
merge these two,
which is
which
nothing
is
but
nothing
L is
but
going
L
to be
is going
3
to be 3
and R is
and
going
R
to
is
be
going to be
1 comma
1
5,
comma 5,
correct?
correct?
So
So
now we are going
now
to
we are
merge
going to
and
merge
count
and count
3
3 and 3
and 1
and
comma
1
5.
comma
Shall
5.
we do that?
Shall we do that?
Yeah.
We shall do
We
that
shall do
fast.
that fast.
So
So
3
3
and
and
1 comma
1
5
comma 5.
works.
What?
So the
So
length
the
is going to
length
be
is going to be
1 and 2,
1 and 2,
right?
right?
So
So
k is less
k is
than
less than
uh,
3
3 here,
here,
right?
right?
That means the
That means the
iterations are going to
iterations are
be
going to be
0, 1 and
0, 1 and 2.
Yeah.
Mhm. So
So
initially the
initially
C
the
list
C
is
list is
empty,
empty,
I is
I is
0,
0,
K is
K
0,
is 0,
J is 0,
J is 0,
right?
right?
So I have
So
just,
I have just,
I think
I think
we are
we are
till this
till
point
this
it's
point
done,
it's done,
right? Now we
right?
shall
Now
go
we
into
shall
the
go into the
while loop.
while loop.
Yeah, Uma, you would like to
You
tell?
would like to tell?
No, nothing.
No,
No,
you continue.
you
I'm
continue.
just saying
I'm
that
just saying
explain the
that.
code.
Explain the code.
Oh,
Oh,
okay.
huh.
While k is less than, yes, it is less than m plus n.
Yes.
And if I is 0, no, it is not, right?
Yeah, I is not
Yeah, I
equal
is
to
not
m.
equal to m.
Yeah. Now m is
M is
1,
M
1.
is
right?
1.
Correct.
Okay.
Hmm.
Okay. So we are checking for the second loop. That is also not equal, right? It is
Mhm.
0. J is 0, I think.
Yeah,
Yeah.
So we're going to the third elif loop.
correct.
So now we're checking for the element.
Mm-hmm.
If a of I is less than b of j.
Is it so?
Is it so?
No, right?
No.
No.
Right?
Right?
Then we go to
Then
the
we
else
go to the
part.
else part.
That's fine.
Here comes the
Here comes the
inversion. Good.
inversions.
Yeah, so we are appending that 1 to the list, new list.
So we are
So we
appending.
are appending.
What are we
What are
appending?
we
One
appending?
to the new
1 to the
list.
new
One
Good.
list.
Okay.
new list,
Okay.
and we're incrementing j. J is 1
Uh-huh.
and k is 1.
Yes, one.
Yes,
And
one.
Count
count
equal to
equal to 0 plus m minus I. What is m?
count plus
Count
c
plus
equal
c
to
equal
m.
to
M
m. M minus
minus
I.
1 minus 0, 1.
I. Okay. M
Okay.
is
M
okay.
is
Fine.
okay. Fine.
So what is
So
this? What is this
what is
logic
this
behind
logic
this?
behind this?
M minus
M
I.
minus I.
Huh. Okay.
Okay.
Now I
Now I
understand.
understand.
Because
Because
you tell.
Yeah,
you
you
tell.
carry on. Carry on.
Okay.
Okay.
So just
So just
imagine the case
imagine the case
where we saw
where
in the
we saw in
picture,
the picture,
right?
right?
So if
So
one
if
is
one
here
is here
and if
and
other
if
one is
other one
here,
is here,
right?
right?
How many
How many
inversions does it
inversions
have?
does it have?
Something like that,
Something like that,
or else you
or
have
else
a
you have
different
a
idea?
different idea?
No,
No,
I don't
I
think
don't
it
think
makes
I
sense
make
there.
sense there.
Uma, you tell
Uma,
now.
you
You
tell
have
now.
any
You have
idea?
any idea?
Why?
Why?
Afnan?
Afnan?
Uma, you tell.
Uma, you tell.
No, I'm not getting it. Yeah, Afnan can tell you.
No, no. So I think you were right, Google, that how many ever elements are being, before that, whereas in the original version it should have been after that. So at once, I think this was discussed in the live session also. So
Mm-hmm.
they also told the same thing that wherever we have this kind of condition that we are swapping one element, so everything that came before that also has to be counted. So in one go, we are basically adding that m minus I represents everything that has been previously swapped, right? So we add the count at once. That is the beauty of this particular uh,
Okay.
logic.
Okay.
So
So
probably
probably
we are not
we are
keeping
not
track
keeping
of
track
the
of
count
the count
anywhere. I
anywhere.
think
I think,
we are
right?
not
We are not
keeping track
keeping
of
track
it.
of
Are
it.
we keeping
Are we
track of
keeping
it
track of it
here in this
here in
case?
this case?
No, no, that is the only place.
No,
Yeah.
right?
No, right.
No, no.
Update is only happening
My
at
Just
that
question
my
is that
question is that you are
returning it
returning it
here
here
and
and
merge in
merge
count.
and count.
Okay. Are you
Are
using
you
this
using
part
this part
for the next
for the next
iteration?
iteration
I'm talking.
I'm talking?
Yes, so only in the return part we are using, but internally in the recursion calls it will be used, right? So that is a
Mm-hmm.
different thing. But finally we are returning that, no? In the final return statement, you can see that we are doing b
Mm-hmm.
count of l plus count of r plus count of b. So these three, are added together. So it is basically the number of inversion in the left part, number of inversions in the right part, and then in the I think this is the
Merge part also.
merge part. Yeah. So whatever we counted there in the merge part, we're adding that also. Because see, that inversion count for this L comma count of L is also merging internally, right?
Uh-huh.
So that is not necessarily zero always. It might return something, right? The
Okay.
other part. So that is why we're also adding those together.
Hmm.
I hope it is making some sense at least.
Hmm. Little bit, yeah.
But yeah.
But it's
But it's kind of
Complete only till no. We cannot. I
yeah.
also don't.
yeah, yeah.
Yeah,
Let's
yeah.
go and
Let's
complete.
go and complete it.
Yeah, Uma.
Yeah, Uma.
So this is
So
what we
this
are
is what
done,
we are done,
right?
right?
So count is equal to 1. Yeah.
Hmm. So
Then
I.
again,
So I
going to the loop.
Mm-hmm.
So now again I is 0, so we don't go inside, right?
Correct.
correct.
I
I
is
is
not
not.
I use
updated.
now.
Uh-huh.
J is updated, but J is not equal to n.
Correct.
So we are again coming to the elif part.
Hmm.
Now we are checking if A of I is less than B of J. Yes.
Correct.
Correct.
Because 3 is
Because
less
three
than
is less
5.
than five.
Yeah.
Hmm.
So we are appending to the C list
Okay.
Okay.
and incrementing the I pointer.
Hmm.
Hmm.
I is updated 1 and K is equal to 2.
Good.
Good.
Yeah.
Yeah.
So now what are we doing?
The third
The
Yeah,
third
iteration.
1
iteration.
no. So again we are coming
Hmm.
to the loop. Now I is equal to 1, M is equal to 1. Yes, we are appending 5 now to the
Hmm.
C.
So if we are
So if
appending
we are
5,
appending
yes,
5 to
and
the
we
C
can
and
see
we
that
can see that
count is
count
1.
is 1.
Yeah. So
So
now J is updated and K is updated. Yeah, but anyway, we are going out of the loop, right? Let's just
correct.
keep.
So let's come back here.
Now
That
boot
means,
count is 1.
sorry. So when we see the, shall I check the inversions? Should be
Yeah.
3, 1, 5, right? This is 1. Right. So 3 and 3, 1 and 1, 5 and 5. Yeah, we got one inversion, right? Just like how we got in the code.
But like Afnan said, I'm just having a doubt.
Mhm.
Actually, the computer doesn't have that reference, no. But the program is made in such a way. Is that so?
Yeah,
Something
I
is.
think so. Like something is kind of odd here, right? Like
Yeah,
something.
because
I feel like something we are missing out, right?
yeah, because it doesn't have a reference. The computer doesn't have a reference yet, right? But still, we are getting the inversion.
So no, no.
No,
Gokul,
actually,
one
you see,
thing that
uh, often may I talk 1 minute?
yeah, yeah, okay, sure,
Yeah,
sure.
1 minute. So, Uma, let's take 5 movies. All right. So, can you tell me some movies? Let's say, just say some movies, please.
Movies. Okay,
Thor.
I know. Okay.
Okay.
So,
So, Iron Man,
Spider-Man.
Spider-Man. All right. Next, what do we have? Loki. Right. And then what else we have? Wanda. All right. Okay. So these are all the movies that is being. I mean, the movies that have ever been released. All right. So, tell me some numbers, now, please. I don't want you to give me the order, but you can tell me some numbers.
Yeah, 2, 3, 1 to 5. You asked me to rank.
Yeah, I want you to rank this.
Yeah, yeah, 2, 3,
2,
1,
3, 1,
4,
4,
5.
5. Okay. So this is Uma's ranking. All right. So I'm gonna rank this. So I'm a fan of Iron Man. So I'm gonna put 1. Right. I like it the most. So then goes Spider-Man because he is a childhood. So then goes 2 here. So I have not been a good fan of these two, but Thor will be the third one. So I feel Wanda or Loki, which one? So Wanda, it's okay. 4 and 5. So this is my kind of liking. All right. Okay. So the thing is, so how it will take is that how the computer will organize is that SM. Okay. So then what we have? Thor, right? So Iron Man, Loki, and Wanda. Okay, this is the Uma's order, right, Uma?
Yeah, yeah.
Okay. So now Gokul is coming up. For Gokul, it is Iron Man, probably Spider-Man, right? So then comes Thor, right? So then we have what do we have? We have Wanda. Then goes Loki, right? So that's all. So there is no nothing like you get. So now I'll just try to draw the
So
lines.
now you can draw Gokul, yeah, because there is a reference for you to compare with mine. But
Correct.
in the list, when we are giving only one input, right?
Yeah.
We are just only sorting that internally, that list. Like you can say in this example, according to that, only my rating is there.
Yeah, Uma, wanna tell me something? This Uma's rating. See, Uma's rating is 1, 2, 3, 4, 5. Am I? Isn't it the same here? Tell me. 1,
Pardon? I
2,
didn't get
3,
you.
4, 5. Is this in the same order? Uma, whatever Uma's rating is.
No.
Hey, see, SM, Thor, Iron Man, Loki, and Wanda. This is the Uma's order at the top. Yes or no?
Okay, okay, right. Yeah, yeah, correct.
Okay.
Yeah.
Now Gokul's order is going to come up. So Gokul's order. So first is I am. I am. So how do I numerically tell this? So whatever is Uma's. So this is going to become like 3, right? For SM.
Yeah, Gokul, there is one order. Then when next input is coming, you are drawing a line. You are getting the cross, right? You are getting the
Yeah.
inversion. But in our program, we are giving only one list.
That's right.
So is it automatically? So how that count is already coming, started coming? We are not finding any inversion, right? It's okay. We can go ahead. We don't want. I don't want to drag the time. Okay,
Okay.
let's see the
Yeah.
code
We'll go
complete.
ahead.
Yeah, because we don't want to confuse.
Mhm.
So there is one point, if I may add,
Yeah.
not in this thing actually, in the code itself.
Okay.
That question that how we are getting the order. So what happens is that forget the count for now. What does merge sort do? I mean, like by default we are assuming the order to be A comes first and then B. We have this A of I less than B of J. So that is the default order, right? So we are assuming the list. So whatever list we have, the order which we want it to be in has to be ascending order, right? Because if you pass that merge
Exactly.
sort, it will sort it in ascending order.
Hmm.
So whenever we have the original order, remaining, we don't increase the count. Only when we have a flip, right? So what happens is that as per our convention, A of I should be less than B of J. But whenever it doesn't happen, so the else part, then only we increment the count. So that internal ordering of this ascending order is automatically taken care of by this merging process. I mean, that is implicit. We don't need to have that
Yeah.
reference list with us.
Okay.
So is that making sense somehow?
So what you're
So what
saying
you're
is that
saying is that
this is
this
checking
is
for the
checking for the other. Like these are we are basically
Ascending order.
looking for ascending order, right?
So,
Exactly.
we don't even
It'll
have
always be
huh.
yeah. So as per convention, it will always be ascending order, and you sorted it rightly also in that visualization that you showed, right?
Yeah.
Whatever order the user has, then we sort it in ascending order first.
Hmm.
Then that becomes the reference point. So
Reference
this is
point.
1 2 3 4 5. That will always occur. That will be always happening,
Hmm.
right? And then it becomes the by default it happens that the ascending order becomes the reference point. So
Reference.
that is implicitly taken care of by the fact that we are using this merging process,
Mm-hmm.
right? Yeah.
Yeah, Uma,
Yeah, Uma, you want to say something?
or shall we go
Shall we
further?
go further?
Just, yeah.
All right.
All right.
So we are
So
going
we are
further.
going further. All right.
So while
So
merging
while merging
this list,
this
right?
list, right?
So
So
what did we
what
get?
did we get?
315.
315.
We got
We
I
got
think
I think
one
one
inversion,
inversion,
right? In this
right? In
case.
this case.
So and
So
the
and
output
the
is
output is
135,
135,
right?
right?
With
With
one
one
inversion.
inversion.
Okay. And
Okay.
we have
And we have
24
two
with the
four
zero
with the
So
inversion.
zero
the count
inversion.
B is 1, right?
4.
Now the count B has become 1, right?
The
The
count
count
B
B
has become
has become
1.
one.
Yeah, because the last expression we are getting the count as 1, right? That will be given to the count B, right? Assigned to the count B.
Hmm. Okay.
Okay.
Am I right? Correct?
I also
I
think
also
so.
think so.
Also think so.
Also think so.
Okay.
Okay.
Now,
Okay.
coming.
Coming. Wait. One
Now I
second.
can
Now I
give
can
you
give you more
good
good
explanation.
explanation.
So Uma,
So
you
Uma,
remember
you remember?
that we
Like
had
we
five
had five
elements in the
elements in
list,
the list,
right?
right?
What was
What
it?
was it?
2, 4,
2,
3,
4,
1,
3,
5.
1, 5.
Okay, and
Okay.
we split
And we
it like
split it
this,
like
and
this,
then
and then
this
this
became 2,
became
1,
2,
4,
1, 4.
right?
Right?
So this
So
was
this was
returning
returning
0, and
0,
this was
and this
returning
was
0,
returning 0,
right?
right?
And we
And
had
we had
two elements,
two elements,
only two in
only
this.
two in
I
this.
got it now. 315, we are again merging as 1 3, right? So we are
Exactly.
doing
One
the
minute,
conversion.
That's what I'm
That's what
trying to
I'm
say.
trying to
When
say.
this is
When this is
returning,
returning,
when this is
when this is
returning,
returning, this is
returning a B
returning
list,
a B
which
list,
is nothing
which is
but
nothing but
2,4,
2,4,
right?
Same
right?
thing. Yeah.
Plus, what
Plus,
is the count
what is
of
the count of
this one? It
this
is
one?
0,
It is 0,
0.
right?
Yeah.
0 plus
0
0
plus
plus
0
after
plus
while merging
while
we got the
merging we
count
got
as
the
0,
count as 0,
Yeah.
right?
right?
So
So
2 comma
2
4
comma 4
plus 0 plus
plus
0
0
plus
plus 0
0.
plus
So
0.
that's
So
what is
that's
there
what
in
is
the
there in
left
the
hand side,
left hand side,
right?
right?
Yeah.
I think this is
This
supposed to
is
be 0.
supposed to be 0.
Sorry for that. Yeah. So same
So
was
same was
happening to this
happening to
point
this
also.
point
For
also.
1
For
comma 5
1 comma 5
individually, it
individually,
returned
it
0,
returned 0,
right?
right?
3 also it
3 also
returned
it returned
0.
0.
But while
But
merging
while
it,
merging it, we got
it is
it
basically
is
0
basically
plus
0
0
plus
plus
0
1,
plus 1,
right?
right?
Yeah.
While merging,
While
we are
merging, we are
returning
returning
merged.
Internally itself with the, like Afnan said, the ascending order is changing, inversion is happening, right?
Mm-hmm.
In the original list, we are having 315, but we are actually arranging 135. So that itself, the inversion happened, right? That is why we are
Correct.
getting that one, I think.
Probably, yeah.
probably. Yeah.
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 So now
So
we are
now
going to
we are
try
gonna
to
try
merge
to
these
merge
two.
these two.
2, 4 and
2,
1,
4
3,
and
4. Shall we
135.
try
Shall
that?
we try that
The code?
with the code?
Yeah.
So everything will be
Everything will
clear
be clear with that
if you do that,
if you do that.
right?
Right?
So 2
So
comma
2
Let it
comma
be 2. Yeah.
2 comma
2
4
comma
is
4
one
is
list,
one list.
right?
Right?
So what's the
So
other
what's the
list?
other list?
1, 3,
1,
5, I
3,
think.
5.
135.
Yeah,
Yeah,
that's right.
that's
So
right.
we have it
So
at
we
the
have it
bottom
at the
also.
bottom also.
Yeah, Uma.
Yeah,
So
Uma.
now
So
the
now
length
the
is
length is
2
2
and 3.
and 3.
2 and 3. Yeah.
Yeah. The
The
iterations are going
iterations
So
are
to
going
it
to
goes
less than or
less
equal
than or
to
equal
4.
to
Up to
4 or
4.
5.
4 or 5.
5?
5.
No,
Yeah,
4.
Yeah.
Less than ampersand, right?
yeah.
Yeah.
Right or wrong?
Right or wrong?
Yeah, correct. It is one. It is said less than, not equal to, right?
Yes, yes.
Yes, yes.
So I is not equal to m,
Mm-hmm.
and j is not equal to n.
All right.
Right?
These two are
These
not
two are not
happening.
happening.
So we are
So we
checking
are checking
if A of
A of
I
I
is less than
is
B
less
of
than B
J,
of J.
A of I
A
is
of I
2
is
and
2
B of
and B
J
of
is
J is
1.
1.
But yeah,
But
this
yeah,
condition
this
is not
condition is not
satisfied.
satisfied.
So we are going
So
to
we are
else
going to
part,
else part,
right?
right?
Yeah.
So if we go to
If we
else
go
part,
to else part,
so we add
so
1
we add 1 to this.
right? Probably.
Before that, I have one doubt, Gokul.
Tell me.
Yeah,
The
tell me.
count, no, I said deep count. It may not be deep count, right? Because internally the 135 is merged. So is it count R in that right hand side list while we are merging? That one is which
That one,
count?
what is this
What
one?
is this 1?
That is what you're
That is
saying,
what you're
right?
saying, right?
Exactly.
Yeah,
Exactly.
yeah.
That's right.
So that
So
Count anywhere, count
R is
anywhere.
that count.
that count.
So while
So
the
while
final
the
list
final
will have a
list will
count,
have a
right?
count, right?
You're right,
You're
Uma.
right, Uma. You're right.
Uma,
Uma,
Yeah,
you're right.
you're
Actually.
right actually.
it's a count R, right?
Correct.
Correct.
So the right
So
hand
the
side,
right hand side,
that one
that
we are
one
getting,
we are
right?
getting,
That's
right?
what you're
That's what
asking,
you're
I think,
asking, I
right?
think, right?
Yeah.
The count
The count
for R is
for
going
R
to be
is going
1.
to be
You're
1.
right.
You're right.
Where is the
Where is
confusion?
the
You're right.
confusion? You're right.
Okay.
Are you still
Are you
still not?
still not?
It's okay. We can go ahead. At last, I will understand.
Okay.
Yeah.
Okay. Okay.
Right. So
Right.
this
So
is
this
count
is
equal to
count
1.
equal to
I
1.
think
I think
1 is
1
added.
is added.
So it's a
So
similar
it's a
thing,
similar
right?
thing, right?
So let's see
So
what
let's see
is going to
what
happen
is going to
next.
happen next.
So for
So
2 it
for
is,
2 it
right?
is, right?
Yeah.
For 2,
For 2,
um,
um,
so I is
so I
I is
I is
not equal to
not
M,
equal to M,
and J is
and
not
J is
equal to
not
N
equal
because
to
J
N
is
because
1
J
and
is
N
1
is
and N is
actually 3,
actually 3,
right?
right?
And A
And
of
A
I.
of I.
So 2
Yes, it
So 2
is
is.
less
is
than
less
3,
than
right?
3,
Yeah,
right?
that's
Yeah,
correct.
that's
2
correct.
Yeah.
is less than
Less
3.
than
2.
3.
So we
So
append
we append
2 to
2
this,
to this,
right?
right?
Yeah. I is equal to 1 and K is equal to 2.
A equal
A
to
equal to
2.
2.
Right? We don't need to
We
increase
don't
it.
need to
So
increase it.
again, entering the loop.
Now 2 is
Now
done.
2 is
Now we are
done.
going
Now
to
we are
3,
going to 3,
Yeah.
right?
right?
So when it
So
comes
when
to
it
3,
comes to 3,
um,
um,
what are we going to
what are
check?
we going to check?
This is
is
not
not
This
equal to.
satisfied.
right?
Yeah.
Yeah.
So J is
So
not
J is
equal
not
to N
equal to
because
N
J
because
is 2
J
and
is 2
N
and
is
N
3.
is 3,
Correct?
correct?
Yeah.
Okay. So
So
A of I less than B of J. So
now
we're checking
now
4 is,
4
if we are
is,
checking
if we are
4,
checking
if 4 is
if
less
4
than
is less
3,
than 3,
right?
3.
right?
But that's
But
not the
that's
case.
not
We
the
go to
case.
the
We
else
go
part.
to the else part.
Else part. Yeah.
So we
So we
put 3
put 3
here.
here.
And wait a
And
minute,
wait
the
a minute, the
counter, I was
counter, I
putting
was
M
putting
minus
M
I.
minus
Why was
I.
I
Why
putting
was
M
I putting
minus?
M
Okay,
minus
I mean,
I?
I was
I mean, I
adding
was
1,
adding 1 on,
but we are
but we
supposed
are
to add
supposed to
more.
add more.
Exactly. This is where.
Count plus 1 plus 1.
Sorry, Uma?
Sorry,
Now
Ma?
only entering the second count, right?
Hmm.
Hmm.
Okay, once
Okay,
again,
once again, once again.
That's right.
That's right.
I was
I was
just doing like
just
how
doing
we
like
used
how
to
we
do
used to do
in
in
terms of mod
terms of
sort.
mod sort.
1 minute.
1 minute.
So
So
for during
for
the first
during the first
iteration,
iteration,
right?
right?
That's okay.
That's okay.
Once
Once
we have
we
1.
have 1,
So
so
we
we go
during the
for
first
we
iteration
first
itself,
iteration,
we come to
we come to
we
the
increase
we
it, right?
increase it, right?
During the first
During the
iteration
first
Yeah.
itself, we are
iteration, we are
increasing.
We
increasing.
came only once to that loop. Yeah. So the count is only 1.
Wait,
Right.
k equal
K
to
equal
1.
to 1.
No, it's not
No, it's
count
not
equal to
count
1.
equal
See,
to 1.
count
See,
plus
count
equal to
plus
m
equal to
minus
M
I.
minus I.
Uma, look at this.
Look at
Count
this.
plus
Count
equal
plus
to
equal
m
to
minus
M
I.
minus I.
Yeah,
So
we counted last time as 1. It came as 1, Gokul. M minus I only came as 1.
No,
No.
I is 0.
I
No?
is 0, no?
Uma.
Come on.
Yeah, at that time M was 1. That is why we got as 1.
M is
Is it
2
M is
correct?
here.
2 here.
M is 2
M is
here.
2 here.
Sir, I'm also
Here,
confused.
not here. Okay, you're asking about here. Okay.
Yeah,
Yeah,
this point
this
I'm
point
talking
I'm
about.
talking about.
Yeah.
During the
I
first
During the
have.
iteration,
first,
we missed
we
this
missed this
actually.
actually.
Yeah, 2 minus 0 is 2. Yeah.
Yeah,
Yeah,
and
and
this will
this
tell
will
us
tell
how
us how
why the
why
count
the
is
count is 2.
So why it is 2, it should be 3.
why it should be
Why it
3.
should be 3?
Mahi,
Mahi,
what is
what
M?
is M?
But why did you delete the C list, Gokul? We have added,
So
no?
actually,
Actually,
I'm
actually,
coming
I'm
right from
coming
the
right
start,
from the start, Uma.
Uma.
Uma?
Okay, then how the count is 2?
That's what I'm
That's what
telling
I'm
you.
telling
So
you. So
let's go from
let's
the
go
start.
from the start.
Okay,
Okay.
I wanna.
I
This is
wanna. This
important.
is important.
J equal to
J
0
equal to 0
and count
and
equal to
count equal to
0, right?
0, right?
Okay.
During the first
During the first
iteration,
iteration,
what do we take?
what do you take?
Yeah, during
Yeah,
the first
during the
iteration.
first iteration.
Okay,
Okay,
I is not
I
equal
is
to
not
M,
equal to M,
right?
right?
Because I is
Because
0
I is 0
and
and
M is 2.
M is 2.
Yeah.
J is also
J is also
0 and
0
3,
and 3,
0 is not
0
equal
is
to
not
3.
equal to 3.
Right.
Right.
A of I,
A of
which
I,
is
which
2,
is 2,
is
is
not
not
2 is
2
not
is not
less than
less
1.
than 1.
Correct. So
Yeah,
this
so
is
it comes
condition
to
is
else
not
part. Yeah.
satisfied.
Right.
Okay. So
Okay.
we go to
So
the
we
else
go to the
part.
else part.
That means
Yeah.
we are appending b of j, which is 1.
Okay, got it. 2
Correct.
minus 1. Yeah, okay, got it. Yeah. 2 minus 0 is 2.
Exactly. So j, we are trying to increase 1 here, and then k, we are increasing 1 here. Then now tell me, what is m minus I? What is m? 2.
2 is 2, yeah. 2 minus
What
0
is
is
I?
2.
0. Ravina, you tell me, what is the count?
So, but why we are not adding the previous count here? Because it is plus equal to. So previous it was 1 plus 2, then it
Where
will
is
be
previous
3,
one?
and
Which iteration? First iteration, we are in the
in
first.
the previous iteration we have done it like count equals to 1.
No, that previous iteration we deleted. We are coming again from the previous iteration. Ravina, we are in the first iteration, not the previous iteration.
Okay.
Okay, for the first iteration itself, we made a mistake. That's why I'm coming. I'm stressing on this point. Okay. Look at this. What is happening? For the first iteration, that's what we are coming to the first iteration. I deleted everything, right, Uma? Ravina. Hello.
Yes, sir.
See, I
Still
deleted
got
everything.
it.
So m minus I is, it is 2 here. And why is this 2? Afnan.
Okay, so what happens is that whenever we see something that is not that is changing the order, right? So like remember that intersection thing. So whenever something is getting swapped, like, so for the lack of a better word, so whenever something is being swapped, everything that is left, which was previously there but is left out,
Hmm.
that is also that can also be part of that swap, right? So we're taking it in pairs, right? So that we are not doing here. We're not comparing it pairwise. So how do we take into account those things which may be potentially also, could be made of out of them also? So that is taken care of by this m minus I. So whatever was previously there in this list, length of a, and we have made one swap, so whatever was previously there also, that also can be part of swap. And whatever, whenever we compare that this element with those which are already present in a, that then also will increment count once, right? So I hope you're getting my point.
Like, Afnan, I have a doubt. You mean like one count was for 3, 5, and one was for 2, 1, because we slapped 3, 5 also, and now 2, 1. So there are two
Yeah,
counts, is it?
so see what happens is that 2 4, how many elements we have? Two elements here, no, in this first list,
Correct.
2 4, right? So we sorry, so we are at 1 now. We see 1. So one thing we can do is we can say that, okay, 4 is there, but 1 should come before 4, so there is one inversion, so that is 1. But then we see this 2 again, right? So 2, there is one inversion also, so 2, 1 should come before 2 also, so that is giving us 2, no? M minus I is 2 because of the fact that 1 can come before 4, so that is one inversion, and 1 can also come before 1 2, so that is two inversions in total, right?
Gokul, shall I say? I just
Yeah.
basic. We are comparing only M and I, right?
Correct.
So basically, if M is the length of A, so if A has a sorted list, we will not get the inversion at all. See here, M minus I. So if here we are skipping these two elements of A, M is equal to the length, then we are adding the first one of the B element.
Exactly.
Is that reason too we are getting maybe?
I feel so.
Because we are skipping that M and then we are going to the end, the B part, and then we are adding the from B we are adding 1. That is why we are getting the count as 2. Something like that. I'm not sure.
Yeah. Actually, everyone is thinking very similarly. Right.
Yeah, because M minus I, we are comparing the M element. So if in case next time we can try the input as in the A something like a sorted one, then we may not get this count. I think so.
Let me tell.
Let us see.
Okay,
But
could,
anyway,
could you please sorry, could you please draw this in this list itself? Could you please draw it in the paint and draw the lines also? Maybe you able to will be able to get it. So 2 4 1 3 5, and then you can join the lines. We'll see
Sure.
what it gives. I think, yeah, that 2 will come up there, and the reason is, because this 2 4. So if we talk about 1, then uh,
Afnan,
1.
I think I kind of got a logic there for that. How to tell that? May I tell?
Okay, okay, sure, yeah, sure, of course.
So, see, this is the order that we have. Just imagine, we are just going to add the list to these two lists together. All right. So this is order. It is now, but it is supposed to be one. I mean, 1, 2, 3, 4, 5. Right. So that means, so this one should go 2 steps further. Right. 1, 2. Okay.
Exactly.
So what I'm going to do is
I'm going
I'm going to take this and push to the one two steps further. So now we have done two steps, right? So one is perfect, two is perfect, but four, yeah, four and three. I think four should go one step back. Let's take like that, right? Yeah.
All right, that is fine. So this is also counting that fact that 3 also
Exactly.
should
And now
come before.
we'll get three.
Hmm.
Now we'll get three, right? I mean, this also is going to give us a count of three at the end of the iterations.
Yeah. Okay. So
Uh,
the question was only the first iteration why we are getting 2.
mhm.
So that I think you put it rightly that since we are A is like going before 3 and 2, so 2 elements are there already. So that
Correct.
is why we are doing. But in the case of 2 4 also, like
Mhm.
in this case we have 2 4. So one we first go to 2 1 4, right? 2 1 4 and then 1 2 4, right? Like that. Before one reaches its correct position, we have to jump
Uh-huh.
2 times.
That's right. So you're
That
going to
is what I'm saying.
two
Yeah.
one four, right?
2 1 4 and then 1 2 4. Exactly. That is why we're getting 2 there. So
Two
instead of doing this 2 jumps, what we are doing is we are taking whatever was already present in the other list, the first list, length of A, which is M, and then subtracting it with whatever we are at with current iteration. So that
Uh-huh.
is why we are, because we know it has to jump that many times. So that is why
Exactly.
we are just yeah.
We're just
Yeah. Oh,
going on.
now I think it will make some sense.
Uma, little bit okay?
Yeah, got it. Because we are considering the first list. That's why the given m. That is why we are calculating m minus I. The reason for that is the first list A we are taking as a m now, the length of the first list.
Correct.
Exactly.
So it
M
is
is the length
supposed
of
to
the
be
first list.
come as a length A first, B first. So whichever if it is crossed, then we're taking the reference as a m. So we are taking the count in the inversion. Yeah, got it. I was thinking why the m is there. So now got it.
Now you got it. No?
Yeah.
Okay. So we have one in here. What about two? When we put okay, I mean let's finish these off, all right? So we have a count of three. Now during the second iteration, right? So what do we do in the second iteration? So probably what? I is still zero, right? So I is not equal to m. J is not equal to n because j is one. One is not equal to three, right? So a of I is two,
Less
and b of j is three. B of j is three. Two is less than three. That's right. So I'm gonna put two here, right? I'm gonna
I
increase.
is equal to 1 and K is 2.
Yeah, k is two. Very good. Okay.
Yeah.
So now we go to three.
Yeah.
So third iteration is three. So I is not equal to m. J is not equal to n, and a of I. So a of I is 4 in this case, but b of j is 3. So 4 is not less than 3. So we go to the else condition, right?
Yeah. Now the count, because the 4 and 3 is interchanged, no? So again the count will get the count.
3 here, right? And then
Yeah.
k will become 3, and j will become 2. The
The
count
count
is
is 3.
plus 1.
Sorry.
Yeah, that's right.
N minus 1.
M minus I. So I is 1, no? And M is
Yeah.
2.
M is...
M is 2. Always. It's fixed.
Okay. 3.
Right. So count we got 3. Right? Now we go to the next iteration. Okay? So I equals M.
Yeah, we go to the elif condition, A of I less than B of J.
So then we will add 4 to this, right? And then during the next iteration, so if we are adding 4 to that, I think probably I is getting increased, right? So 2.
Yeah. 2.
So now I will become equal to M, right? I is equal to M. So this condition will be satisfied, and we increase J. I think I was supposed to increase this last time itself. Now this is 5, and we are going to append 5 to this list, right? And the count we are going to return as 3.
Yeah.
Good. So this is returning as 3. So for the left list for 2, 4, the left list is 2, 4, and the count is what was the count? 0.
0, yeah.
L count.
So we got 1, right?
Yeah, very good. So right list, what is that? 1, 3, 5, and the count was 1. Okay. So for B, so B is nothing but 1, 2, 3, 4, 5. The total list, right? And the count for that is 3. Okay. So return B. B is nothing but the whole list. This whole list we are returning. Count of L plus R plus B. So L is 0, R is 1, B is
3.
Very good.
Very good.
So and we
So and
at the
we at
end
the
we
end we
returned.
returned.
It was
It was L of like
Yeah.
L of
huh.
Oof.
Oof.
It was really
It was
good.
really good.
It was really
It was
good.
really good.
So
So
were you guys
were you
able to
guys able to
understand at
understand
the end?
at the end?
And the small
So it's
code.
small code.
This is how
This is how
regression will be.
regression will be.
Any doubts
Any
for this?
doubts for this?
I think we are
I
done
think we are
with this,
done with this part.
guys.
Guys,
Hello.
hello.
Is everyone
Is
okay with
everyone
the
okay
how
with the
finding
how
the
finding
number
the
of
number of
inversions
inversions
given?
given?
Ravina,
Ravina,
Mahi, any
Mahi,
doubts?
any doubts?
Yes, it's absolutely clear, sir.
Very good.
Very good.
Okay. So
So
shall we?
shall we go to the next one?
Mahi,
Mahi,
you want to say
you want
something?
to say something?
No, it's clear.
Very good.
Very good.
So let's
So
go
let's
and
go
see
and see
the.
the.
So I think we
I
don't
think
have
we don't have
time to
time
explore
to
the code,
explore the
but
code.
what
But
we'll do
what
is
we'll do is
explore the
explore the
theory part at
theory
least.
part at
Alright?
least. Alright?
Uma, you told
Uma,
that you
you
were
told that
having
you are
confusion
having
with the
confusion
finding
with
the
the finding the
closest pair of
closest pair
points.
of points.
No, I am not getting only the code, not this is fine. Theory is fine.
But still, you
But
can
still,
let us
you can
know,
let
right?
us know, right?
Let
Others,
others
Yeah.
know.
let others
No, I don't explain you. Please go ahead.
Okay.
know. Okay.
So there is
So
something
there is
like
something like
I think sir
I
used
think
to
sir used to
explain us with
explain us with
the
the
game, right? Video
game,
game,
right? Video game,
right?
right?
So ask.
So
I think there is a pictures that they showed in the. You can go to the slide and check for the squares. That's how they explain this closest pair.
Okay. That was
that was
interesting for
interesting for
finding the number of
finding the number of
inversions. Okay. Oh wait.
Oh wait,
Still
is
in the
this
first
still in
one?
the first
This
question?
is the
Like, this
first
is
one,
the
right?
first
No,
one,
this
right?
is
Now
the
this is the
closest pair,
closest pair,
second.
second lecture.
Okay.
Okay.
I'll go to the
I'll
end
go to the
of
end of
this
this
thing. Yeah.
thing. Yeah.
So the
So
statement
the
is
statement
we
is
have
we
several
have
objects
several
on the
objects on
screen,
the screen,
right?
right?
So find the
So find
closest
the
pair of
closest
the
pair of the
objects.
objects.
Okay.
Okay.
Naive
Naive
algorithm
algorithm
n
is
square.
n square.
For each
For
pair of
each pair
objects,
of
compute
object,
their
compute their
distance,
distance,
report
report
the
the
minimum
minimum
distance
distance
across all
across all
pairs.
pairs.
Okay.
Okay.
So,
So
do you understand
do you
what is the
understand what is
context
the
here,
context here?
Ravina,
Ravina,
Mahi,
Mahi,
Vicky,
Vicky, Vicky.
hello?
Hello.
No, sir.
Okay.
Okay.
So,
So
do you remember
do you
the video
remember the
games
video
we
games
used
which
to
we
play
used to play
earlier,
earlier,
right? In
right?
our
In our childhood?
something like this,
Something like this.
Yeah, Mario Forever.
whatever.
Whatever.
Okay, let's
Okay,
take
let's
it.
take like,
That's
yeah,
a
that's
very
a very
interesting thing.
interesting thing.
So we have
So we
Mr.
have
Mario
Mr.
here,
Mario here,
right?
right?
Okay,
Okay.
and
And
there'll be some
there'll be some
bullets coming
bullets
from
coming
some
from
place,
some
right?
place, right?
Something like
Something
this.
like this.
Yes or no?
Yes or no?
Which will try
Which
to
will try
hit
to hit
Mario.
Mario.
Yes or no?
Yes or no?
Or some
Or
that
some that
mushrooms will what do you
mushrooms, or
call it
what do
as?
you call it as?
Something like
Something
mushroom
like
will
mushroom
keep
will
roaming
keep
here and
roaming
there,
here and there,
right?
right?
Yes.
Ravina?
Ravina?
Okay.
Okay.
So if
So if
Turtles also.
turtles,
turtles,
right?
that's right.
Okay. So
Okay.
if
So if
Mario,
Mario,
wherever
or
the
wherever
Mario's
the
location
Mario's
is,
location is,
Mario's
if
location
Mario's
is
location
equal
is
to
equal
the
to
turtle's
the
location,
turtle's
be it
location,
any
be it
turtle
any
in the
turtle in
screen,
the screen,
all right?
all right,
Then you're
then
out.
you're out.
Yes or no?
Yes or no?
Am I right or
Am
wrong?
I right or wrong?
If
If
Mario
Mario
goes and hits
Yes,
goes
the
and hits
sir.
the
turtle,
turtle,
then
then
Mario is dead.
Mario is dead.
Right? Poison
Right?
comes
Poison
and
comes
hits the
and hits
Mario,
the
and he
Mario,
is
and
dead.
he's dead.
Right?
Right?
So
So
that is what
that is
the
what the
thing is,
thing
right?
is,
So
right? So
Mario can be
Mario can
anywhere.
be
He
anywhere.
can be
He can be
jumping. He can
jumping.
be
He
around
can be
this
around this
place, right?
place, right?
He can be
He
at
can
this
be at this
point,
point,
and then he can
and then
come
he
back
can come back
here. So
here. So
at a given
at a
instant
given
of
instant
time,
of time,
we are supposed
we are
to find
supposed
out
to find
what is
out
the distance.
what
Okay,
is the
we have
distance.
one
Okay, we
turtle
have
here.
one turtle
So let's
here.
say we
So
have
let's say
some
we
that
have some that
what do you call it
what do you
as
call it as
that plant,
that
right?
plant,
You
right?
remember
You remember
the plant which
the
goes up
plant
and
which
down,
goes up and down,
right? So
right?
that
So
plant is
that plant
somewhat
is
around
somewhat
here
around here
over a bit.
over a big.
All right.
All right.
So we need to
So we need to
compare the
compare
distance
the
of
distance of
Mario
Mario from
between all the
between all
points,
the points,
right?
right?
And we'll give
And
the
we'll give
condition
the
saying
condition
that
saying
if
that if
a
a
plant
plant
location equal
location
to
equal
Mario
to Mario
location,
location,
out.
out.
That's one
That's
condition.
one condition.
Okay.
Okay.
If
If
turtle
turtle
location
And
equal
location
if the
to
equal to
distance is zero,
huh,
the
if
distance
the
if the
distance
between
is
distance
zero,
them.
is zero,
huh, correct.
correct.
Uh,
Uh,
so
so
yeah.
yeah.
So if that is
So
the
if
case,
that is
then
the case, then
that's what the
that's
whole
what the
point
whole
is.
point is.
We are trying to
We are
find
trying
out
to
the
find out
closest
the
pair.
closest pair.
That
So that
computation should come
computation
very
should come very
immediately,
immediately,
right?
right?
Like it should be
Like it should be
instantaneous.
instantaneous.
right?
Right.
So
So,
that's what the
that's
whole
what the
point.
whole
I
point.
think
I
let's
think
take a
let's
go.
take a
I
go.
mean, that's
I mean, that's
enough
enough
introduction,
introduction,
right?
right?
So the naive
The naive
algorithm is,
algorithm is,
so let's
so let's
consider that
consider
you
that
have
you have
this is
this is
Mario, and you
Mario,
have
and you
like
have like 5
5 points. Like
points.
you
Like
have
you
total
have total
pixels are
pixels
there,
are
right?
there, right?
So many
So many
pixels are there,
pixels are there,
right?
right?
So
So,
in given
in
point
given
of
point
time,
of
what is
time,
the
what is
distance
the
between
distance between
Mario and
Mario and
all the
all the
points? You
points?
need to
You need to
compare, right?
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 So you need to
You need
compare
to
with all
compare
the
with all
points.
the points.
Just
Just
imagine you have
imagine you have 1,000
points,
points,
1,000 pixels,
1,000 pixels,
right?
right?
You are
You
supposed
are
to
supposed to
be in only
be in
one
only
place,
one place,
right?
right?
So you need to
So you need
compare
to
your
compare your
distance with
distance with
all the
all the
1,000
1,000
points.
points.
So it will
So
take
it will
n
take
square,
n
like
square, like
computing the
computing
distance
the distance
algorithm
algorithm
using the.
using
But
that.
the clever
But the
No,
clever
algorithm
sir,
is
it
algorithm,
will take only n. It will take only n.
how?
how?
If there is 1 point, then comparing its
So,
distance with 1,000 points, it will take n.
so what is the
So what
formula
is the
for that,
formula for that,
Ravina?
Ravina?
The point.
The point.
If you
So
want to
if you
find
want
the
to
distance
find the
between
distance
any
between
two
any
points,
2 points,
I come here.
I come here.
Hmm.
So you said that we have to compare 1 point with the 1,000 points,
Correct.
then it will take 1,000 unit time
1,000 times the
only.
1,000 times
distance.
the distance.
1,000 times.
1,000 times the.
Yeah, that's right.
Yeah, that's right.
Okay.
Okay.
So
So
one point
1 point
with
with
1,000 points,
1,000 points,
right? So
right? So
let us
let's
compare first
compare
point with
first
the
point with
second
the
point.
second point.
Okay, if you want
Okay,
to
if you want to calculate the distance,
what is the
what is the
complexity?
complexity?
Look at this.
Look at this.
So you are
So you are
squaring it
squaring
and
it
then
and then
taking a root of
taking
it.
a root of it.
Ravina?
Ravina?
So, Google, may I interrupt?
Yeah, please,
Yeah,
please.
A
please,
small
please.
point here. So,
Yeah.
yeah,
Yeah.
I think she's saying correctly that whenever we have 1 point, right? So that point is constant. Like you have taken Mario, right? So as an example, so that is constant, right? Mario is at one place, and then we are comparing, his location from all the other things.
Hmm.
So that will be O of n, which is correct. That is okay. But here in this, problem, we need to find out, compare the distance of every point with every other point. So that is not
Okay, okay,
like
Okay.
one point is not fixed. Yeah, every point with every other point, and then we have to report whichever of the two,
Yeah,
which pair
here
is.
it will be n square. I
okay,
got
okay.
Yeah.
it. I got it.
Hmm.
Yeah, yeah.
Yeah,
Thanks
yeah.
for
So
that.
Thanks for
then,
that.
Hmm.
and then we'll report the minimum distance among them, so as to report the closest object, right? So we have so many balls there, and we have to, find out which ball is nearest to the other ball, right? So that is something like that.
Hmm. Which two balls
Which
are
two
very
balls are
close
very close
together?
together?
Exactly,
Okay,
exactly.
okay. So we took
So
a
we
Mario
took a Mario
example,
example, but
but sir used to
sir
give a
used to
different
give a different
example of
example of
asteroids, right?
asteroids, right?
Okay,
Okay,
that's okay.
that's okay.
So
So
is it
is
okay?
it okay?
I mean,
I
any
mean,
doubts
any
with that
doubts with that
complexity?
complexity?
Why it
Why
is
it
big of
is
n
big of
square?
n square?
Yeah, that's
Yeah,
what.
that's what. See,
Compute
compute
distance
distance
for
for
every pair of
every pair
points.
of points.
Okay.
Okay.
So
So
how it will
how
look
it will
like?
look
So
like? So
we have
we
like
have
five
like
points.
five
Okay.
points. Okay.
So
So
for I
for I
in
in
five range of
range
five,
of five,
right?
right?
So
So
for the
for
first
the
point,
first
we need to
point, we need to
compare it with
compare it with
one.
one.
One is not
One is
required,
not
but
required, but
it will be
it
like
will be like
two,
two,
three,
three,
four,
four,
five,
five,
right?
right?
So n
So
into
n
n
into n
minus one.
minus one.
Somewhat it will go
Somewhat it
like
will go
this,
like
right?
this, right?
After?
Okay.
Correct, correct, exactly,
So
exactly.
that's
So
why
that's
the
why the
complexity is
complexity
going
is
for big
going
O
for
n
big
square.
O.
And even if we add that upon 2 here, right? So that 2 divisor, it will not make a difference because you're just taking the asymptotic
Yeah,
complexity. So
asymptotic
you will not
complexity,
consider
not
that constant, right?
uh,
Yeah, exactly. So that is correct. That is n of n squared. Correct.
that's right.
That's right.
Right.
All right.
So
So
finding the
finding the
closest pair of
closest pair of
points if
points,
it is
if it is
just one
just one
dimension.
dimension.
Okay.
Okay.
Let's go
Let's
further
go
to the
further to the
bottom.
bottom.
Uma, are you
Uma, are
able to
you
follow
able to follow?
the
Yeah,
theory?
yeah,
Okay.
yeah.
Okay. So find the
So
closest
find the
pair of
closest pair of
points.
points.
So given
So given
n
n
one
one
dimensional
dimension
points, find the
points, find
closest
the
pair.
closest pair.
Okay.
Okay.
How are they
How
doing
are they
this?
doing this?
Any
Any
suggestions here,
suggestions
guys?
here, guys?
Sort the
Sort
points.
the
Okay.
points. Okay.
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 Let's say like
Let's
this.
say like
So we
this.
have
So
a
we have
straight
a
line,
straight line,
right?
right?
So
So
this is the
this is the
0th point.
zeroth point.
Okay.
Okay.
So
So
so this
so
is,
this is,
let's say,
let's say
100th point.
100th point.
Okay.
Okay.
I have a
I have
point
a
at
point at
25.
25.
Okay.
Okay.
I have a
I have
point
a
at
point at
this is,
this
let's
is,
say,
let's say
46. I have
46. I
another
have
point
another
at
point at
50.
50.
I have
I
another
have another
point at
point at
57.
7.
Okay. I have
Okay. I
another
have
point
another
at
point at
71.
71.
Okay.
Okay.
And let's say
And
this is
let's say this is
85.
85.
Right. We
Right.
have so many
We have so
points.
many points.
Okay, how many points we have?
points we have? 1, 2, 3,
4,
4,
5, 6,
5,
7,
6,
8.
7,
8
8.
points
8
we have.
points we have.
So
So
give me
give
the
me the
closest.
closest.
How do we do
How
that?
do we do that?
So we can do it like KNN.
Sorry?
Sorry?
Don't go to
Don't go
MLT.
to
Like
MLT.
what?
Don't go to
Don't
MLT.
go to
Like
MLT.
we can find the distance from every point, and
Exactly.
then the minimum distance will be the closest.
Mm-hmm.
Hmm?
So
So
how is this
how is this
sort the
sort the
points?
points?
Like why are they
Like why are they sorting it?
sorted?
Sorted
Nearest
nearest the
points or
points or
its neighbors.
neighbors.
So the points
So
are
the
already
points are
sorted,
already sorted,
right?
right?
So and then
So and then
okay,
I
they are
think
just
they are just
comparing the
comparing the
difference.
difference.
So the
So
points
the
could be in
points could
any
be in
order,
any
right?
order, right?
So they can give
They
us
can
the
give us
points
the
in
points in
25,
25,
46,
46,
then
then
0,
0,
85,
85,
70.
70.
Like
Like
so you can give the
you can
point
give
in
the
But
points
anything.
in
this
anything.
is one dimensional only, no?
Exactly.
There is
Exactly.
one dimension.
Yeah.
That is why.
Yeah.
So this is simply like a list, no?
Correct. So
Correct.
70
So
and
70 and
86, whatever it
86,
is.
whatever it is.
So we just need
So
to
we just
compare
need
the
to compare
difference
the
between
difference
these,
between these,
right?
right?
So, and we
So,
can
and we can
probably
probably
put
we can put a
so that
so
sorting
that
is
sorting
what
is
takes
what takes
big of
big of
login.
n log n.
In
Right.
login.
Correct.
So
So
then finding the
then
distance is
finding the
going to
distance
take
is going to take
just for one for
for
loop
one
is
for
enough
loop is enough
to find the
to
distance
find
and
the
then we can
distance
get
and
the
then we
minimum.
can get the minimum.
Right?
Right?
Probably.
Probably.
Yeah, that's okay.
Yeah, that's okay.
So
So
big of
big
n the
of n
scan
the
for the
scan for
minimum
the minimum
separation between
separation
axis,
between axis
left, right,
left
in
side,
sorted order and
sorted order,
nearest point
nearest
p.
point p.
That's what
That's
service
what
is
service
saying.
saying again.
All right.
Correct.
Is that clear
Is that
for all?
clear for all?
Yeah, we can go move ahead.
Great. Okay.
Great. Okay.
So now we go
So
to
now we go
the
to
two
the two
dimensions.
dimensions.
Right.
Right.
So divide and
So divide
conquer.
and conquer.
Split the
Split
points
the
into two
points into
halves
two halves
by vertical
by
line.
vertical line.
Right.
Right.
Recursively compute
Recursively
closest
compute
pair in
closest
each
pair
half.
in each
Okay.
half.
Then
Okay.
for
Then
two
for two
dimensions, how do we
dimensions,
do
how
that
do we do
again?
that again?
So
Um,
what are they saying?
what are they saying here?
We have to split into half. Then in each half, we have to find the closest pair, and then among that closest also we have to compare the crossing pair. Gokul. If
Be
you
like
draw
this.
a box and
So they are
divide
giving
that,
it
They are
like
giving
this,
it
right?
like this, right?
yeah. So on both sides you have to find the
Okay.
closest pair.
So
So
it's gonna be
it's
list
gonna
of
be list
tuples,
of
right? Let's
tuples,
take
right? Let's
list
take
of
a list
tuples.
of tuples.
Works? Will it
Works?
work?
Will it work?
3, 5,
Comma 5
and
Yeah, yeah, it's
and
correct. It will be list of tuples only because we have two coordinates, no? X and Y. So
correct.
we can take this as a
2,
tuple.
2,
Yeah.
and
and
shall
this
be
shall be
minus 2,
minus 2 comma
minus
minus
2.
2.
Then
Then
this shall
this
be
shall be
3,
3
minus
comma minus
2. The other thing
other
shall
thing
be
shall
5,
be 5 comma
minus 4.
minus 4.
Right? So
Right?
we have
So we
1,
have
2, 3,
1,
4,
2,
5
3, 4,
points.
5 points.
Just like how I
Just
have
like how I
plotted
have
the
plotted in
things.
the things.
So how do we
So how do we
compare
compare the compute
this
this
shortest
shortest
distance?
To take the shortest distance in each of the half. There will be one, right? The shortest will be one pair
Now,
now?
in both the sides. Then compare that with the crossing pair.
no, I'm
No,
not
no,
able to
I'm not
follow
able
you.
to
Can you
follow you.
repeat?
Can you repeat?
Take the
Take the
We have to take the shortest in both the halves, the left half and the right half. For example, if you get the shortest will be only one, right? For now, we can
okay. So
assume
I
that
think
I think
this point
this
is saying
point is
split
saying
the
split the
points into
points
two
into
halves
two halves
by vertical
by
line.
vertical
So
line.
we
So
yeah,
should be
you
able
we
to
should be
find
able
the
to
one
find
which
the
is
one
at
which is
the
at the leftmost
and which is at
and
the
which is at the
rightmost,
rightmost.
right?
Am I right?
And then are
And
we
then are
splitting
we
it
splitting
here?
it here?
I mean,
I mean,
no, yeah, your red line is correct. There is no horizontal line, Gokul, only vertical line.
that's right.
that's right.
And then we are finding this
The
left
blue
side of
line
the
is
red
nothing but
line.
the
But the
vertical.
like
Blue line is
blue
nothing
line is
but
nothing but
the
the
axis.
axis.
I just wanted to.
Yeah, okay, got it. So left hand side of the red line and the right hand side, we will get one shortest pair, right?
Um,
Um,
left.
The shortest among all the points.
How do you say?
how do
I'm
you
not
say? I'm not
understanding.
understanding.
You can keep some multiple points. We are
You
getting
want me to put
one
one point?
shortest distance.
Okay.
Okay.
1 point I'm
One
putting
point I'm
here.
putting
One
here.
point I'm
One
putting
point
here.
I'm
All
putting
right.
here. All
Is
right.
this enough?
Is this enough?
Little more. Just we are finding shortest distance, right?
Yeah.
Yeah.
Maybe.
I don't want to
I don't want
confuse
to
this.
confuse that
I
one.
just
I
want to
just
have
want
Okay.
one
to have
shortest
one
So we are
distance.
shortest.
finding the left half also a shortest pair,
All right.
Right?
and the right also we are finding the shortest pair
How are we
among
How
all
are
the
we
finding?
finding it?
That's the
That's
question.
the
shortest
question, right?
distance.
How?
Like
How?
what we did.
Okay.
Okay.
Between any two
Between any
points.
two
Huh?
points, huh?
Yeah.
Okay.
Okay.
So,
So,
Uma, I think
Uma, I think
you got it
you got it
like 70,
like 70,
80%.
80%.
But like,
But
correct me.
like, correct me if
Do you have any
do you
idea
have
on
any
this?
idea on this?
So yeah, Google. So what happens is, see, we have two planes right now. We have divided it, right?
Mhm.
So what are we doing? Essentially, we are applying the same algorithm again to,
Exactly.
yeah,
That's what I
find out
wanted.
the shortest distance again. So within that, sub problem,
Hmm.
there will be again one partition. But the base case, I'm not able to recall exactly what was the base case.
See, that's what.
But that is fine. I mean, for the time being, we can assume that there is one shortest pair in the left part. Then what do? We have a shortest pair in the right part also. So that both of them we can compare and see whichever the distance is minimum. So that will be our minimum, the overall minimum. That is correct. But then there is this tricky part of finding, across whatever is coming across this vertical line. So that is where the what should I say,
Challenging bit.
tricky part. Yeah, yeah, exactly. So that part only, because see, if you assume that we make an assumption that there will be no crossing edges, right? If that is the case, there is no edge that crosses the vertical line. If we make an assumption, such an assumption, then we just find out the minimum distance in the left part, find out the minimum distance pair in the right part, and then among those two, left and right, we'll compare whichever is minimum and report that. That is easy. That is
Okay,
easy.
probably you're saying
But
that
then,
this is the minimum.
yeah,
Thing.
yeah, this is the minimum and maybe this is the minimum, yeah, and then we compare those two, and then we say that okay, this one is the overall minimum, so that is fine. But then the tricky part comes when we have cross edges, right? That can happen,
So
and
something
that
like
will,
this.
I mean, mostly happen. Right? Yeah,
Right.
something like this. Yeah,
Mhm.
then how do we
So probably this should be
eh,
the shortest distance. Right.
exactly.
Hmm.
So then there's this thing of comparing 15 points and all that. So that
But
part also I am not very clear
I,
about.
I, I, I can
I
explain
can
that.
explain that.
So first,
Okay.
let us make sure that others understand this. Mahi, how much did you
How much did you
understand this?
understand this?
Mahi?
Mahi?
Yeah,
No.
I understand that
Tell.
if if there is a line vertical, uh, and if we are dividing both the parts, then we are not able to find points which have the smallest distance if they are dividing in the vertically. If I am able to explain.
Hmm.
Hmm.
So probably
So
when we
probably
go
when
into
we go
that
to the code, I
much
can explain it much
more
more
deeper.
deeper.
But
But
you are right
you're right,
actually.
actually.
So
So
I'll tell you.
I'll tell you
So again, just like
just like
how
how
we have some
we have
points
some
here.
points here.
We have some
We have
points
some
here.
points here.
Correct.
Correct.
So
So
let's say
let's
these
say
2
these
points
2
are the
points are
closest
the
point on
closest
the left
point on
hand
the
side.
left hand side.
Okay,
Okay,
Mahi?
Mahi?
Yeah.
Okay.
Okay.
And in the right
And in
hand
the
side,
right hand side,
these 2
these
points
two
are
points
the
are
closest
the
point.
closest point.
Okay.
Okay.
So of the
So of
like
the
we have
we
another
have
point
another
at
point
this
at this
place, another
place,
point
another
at
point
this
at
place,
this place,
right?
right?
So
So
while
so while
computing the
computing the
distance between
distance between
shortest distance
shortest
for the
distance
right
for
hand
the right
side,
hand side,
what you will
what
do
you will
is
do
you will
is
just
you will
look.
just
I
look.
mean,
I mean,
you will just
you
look
will
at
just look at
the point on
the point
the
on the
you know
you know
how do I
how
hide
do I
it
hide
basically?
it basically.
I'll just take
I'll just take
um. Okay, wait.
wait.
Let me just take a
Let me just take
screenshot. Come on.
come
Okay.
on. Okay.
Yeah.
Yeah.
Ravina.
Ravina.
Okay.
Okay.
See.
See.
So while
So while
computing the
computing the
shortest, like
shortest,
we are trying
we
to
are trying
find
to
the
find
shortest
the
pair among
shortest
the
pair
right
among
hand
the
side.
right hand side.
Okay.
Okay.
This was the
This was
shortest
the
distance
shortest
pair, right,
distance pair,
on the
right,
right hand
on the
side.
right hand side.
Hello,
Hello,
Mahi.
Mahi.
Yes.
Okay. So
Okay.
that's for
So
the
that's
right
for
hand
the
side.
right hand
So
side.
while
So while
computing for the left
computing for
hand
the left
side,
hand
we
side,
do the
we
same
do the
thing.
same thing.
Okay.
Okay.
So we do
So
the
we do the
same thing
same
for
thing
this
for
part.
this part.
Like we
Like
will not
we
see
will
the
not see
points
the
on the right
points on
hand
the right
side, and
hand
we
side,
just
and
see
we
the
just see
points
the
on the left
points on the
hand
left
side,
hand side,
including this
including this
blue color
blue
point.
color point.
Okay.
Okay.
Oh, where is it?
Where is it?
So
So
including the blue
including the
color
blue
point,
color point,
we'll see
we'll
the
see the
okay.
okay.
But at
But
the
at
end,
the end,
eventually,
eventually,
these two
these
could
two
be
could
very
be very
similar,
similar,
very
very
closer,
closer,
right?
right?
So that's what
That's
is what we are
what we are
finding trying
finding,
to
trying
find
to
out. But
find out.
I
But
know
I
it's a
know
little
it's
bit
a little bit
hard to
hard to
understand now,
understand
but
now, but
we'll go
we'll
further
go
and tell
further
you.
and tell you.
Here they have
Here
the
they have the
points.
points.
See, dividing the
Dividing the
points.
points.
Okay, let's
Okay,
go
let's go
down.
down.
That's what I
That's what I
want
want
to
to
tell.
tell.
Divide
Divide
P by
P by
vertically into
vertically
two
into two
halves,
halves.
or to compute here. Closest
So
pair.
this pair.
So are they
So
gonna
are they
mark
gonna
any
mark
points
any
here?
points here?
Yeah. See,
Yeah. See,
Mahi,
Mahi,
dr
DR,
and dq.
and DQ.
Distance between
Distance
the like
between
of
the
the smallest
the
one on the
smallest
right
one on
hand
the
side,
right hand side,
smallest one on the
smallest
left
one
hand
on the
side.
left hand side.
Yeah.
Yeah.
Mm. Oh, Okay, so I can. No, we don't have time. I have to go at 6.
6.
So shall we do this in the next
In the
session?
next session?
Yeah, it's a very big actually to discuss.
It's a little bit
It's a little bit
complicated one.
complicated
There's
one.
a lot of things to go through in that picture itself. Even I am not understanding the end. I'm not getting it.
So at least
So
I
at
just
least I
want
just want
Mahi and
Mahi and
others.
others.
Okay, Mahi, can you
Mahi,
at least
can you
watch
at
this
least watch
lecture
this
once and
lecture
come?
once and come?
Yeah, okay.
Sure, Anshul.
Anshul, okay, Anshul,
One point,
you're not.
Yeah.
Gokul,
Yeah.
there is a live session. They are teaching this whole thing, so they can go through rather than lecture. They can try the live session.
Okay.
Day before yesterday, they completely explained, but it was very tough. But at least they'll get a picture.
Mm-hmm. So just like
So
how we
just like
used to,
how
I
we
think
used to, I think
we might also
we
need
might
to
also
check
need
into
to
the
check
code.
into the
So if
code.
we
So
go
if
and
we
look
go
into the
and look
code,
into
we
the
might
code, we
easily
might
understand
easily
it, right?
understand
We
it,
might
right?
try
We
to
might try to
understand it.
understand it.
No, it is very difficult without going through that theory part. Code is very tough.
Mm-hmm. So
So
pseudocode. This is
pseudocode,
just
this is just
pseudocode. That's
pseudocode.
okay.
That's okay.
Let me see.
Let me see.
Let me see what
Let me see what
we just have
we
this.
just
Yeah,
have like
because
this.
we need to know PY, XY, SY, everything we need to know Gokul. Only then we can go through the code. Otherwise, we can't.
Are they
Are they
calling this
calling this
closest pair
closest pair
function
function
from this
from this
place?
place?
No, right?
No, right? No.
The above one is a pseudocode. This is the actual code.
Okay, let
Okay,
me just
let
go
me
through
just
this.
go
All
through
right.
this. All right.
So let me
So
see
let me
what
see
this
what this
just give an
just
intro
give
of
an
what
intro
the
of
code
what
is.
the
All
code
right.
is. All right.
So we have
So
all
we
the
have all the
points,
points,
basically the
basically
points
the
which we
points
are
which we
supposed
are
to compute
supposed
the
to compute
minimum
the minimum
distance. Correct?
distance. Correct?
Okay.
Okay.
So and we are
Yeah.
So
calling
we
the
are
minimum
calling the
distance of
minimum
the
distance of the
points.
points.
Okay.
Okay.
So that
So that
is what we are
is what
doing,
we are
and we are
doing, and we
sorting
are
the
sorting the
points
points based on.
yeah.
Yeah.
So
X
to
coordinate and Y coordinate. Yeah.
correct.
Correct.
So at the end
So
we'll
at the
get
end we'll get
1, 4.
1, 4.
Wait, let me just
Let
copy
me just
this
copy this
and run it.
and run it.
So it might be. So we are
So
sorting
we
the
are sorting the
points
points,
and
and
py equal to
py equal to
points.
points.
Yeah, okay, that's
Yeah,
just
okay,
the
that's just
points,
the
whatever
points,
points we are
points we
passing
are
in,
passing in.
right?
Right.
Okay.
Okay.
Then py
Then
dot
py
sort
dot
of
sort of
key equal to
equal to
lambda
lambda
x of
x of
minus 1.
minus
So
one.
I think
So I think
I was
I
telling
was
this
telling this
sometime back.
sometime back.
Very there,
Very
Uma?
there, Uma?
Pardon?
So this
So
part,
this
what do
part,
you think
what do
is
you think
happening
is
here? We are
happening here?
sorting
We
it
are
based
sorting
on the
it based
second
on the
point,
second point,
Yeah,
based on the y
based on the
point.
y point.
because it is based on Y coordinate and X is sorted automatically, right? With the
Correct.
first
Correct.
one,
Correct.
Yeah.
X
Yeah.
coordinate. Yeah.
So so px
So
is going
px
to
is
be
going to be
sorted in terms
sorted
of
in terms of
x,
x,
and py
and
is
py
going to
is
be
going to be
sorted points in
sorted
terms
points
of
in terms of
y. I think
Yeah.
if it's connected,
connected.
I can just try to run this. Okay, so then
Okay.
we are
So then
calling
we are calling
round of
round of
minimum
minimum
distance of
distance
px
of
py.
px py.
Like,
Like,
Now, Mahi, you want
Mahi,
me
you
to
want me
print
to
these?
print these?
What is
What
happening?
is happening?
Or is it
Or
okay,
is
right?
it okay,
I
right?
think
I
next
think
time
next time
I'll print and
I'll
show.
print and show.
Okay,
Okay.
we have the
We
minimum
have the
distance
minimum distance
px. Okay,
px. Okay.
px is nothing
Px
but
is
the
nothing but
points
the
sorted
points
in
sorted
terms of
in terms
x,
of x,
and py
and
is
py
nothing but
is
the
nothing but
points
the
which is
points
sorted
which
in
is
terms
sorted
of
in terms of
y, and
y,
this 2
and
is
this
nothing
2
but
is nothing but
the round
the
off
round
value.
off
So we
value.
need to
So you
round it
need to
into
round it
two
into
decimal
two
points.
decimal
That's what
points.
they are
That's what
saying
they
here,
are saying here,
right?
right?
Okay, so we
Okay.
are calling
So
the
we are calling
minimum
the
distance
minimum
of
distance of
that function.
that function.
Okay, let's go
Let's
there.
go there.
So we have the
So we
minimum
have the minimum
distance.
distance.
REC, I don't know.
REC, I don't know.
Fine.
Fine.
So S is
So
going to
S
be
is
the
going to
length
be the
of
length of
px,
px,
which is nothing
which is
but
nothing but
1, 2,
1,
3,
2,
4,
3,
5,
4,
6
5,
points.
6 points.
S is going to
S
be
is going to be
6.
6.
If only
If
2
only
points, 2 or 3
2 or
points
3
are left,
points are left,
return the
return
minimum
the
distance
minimum distance
accordingly. So
accordingly.
we don't need
So
to
we don't need to
calculate
calculate
big things.
big things.
Okay.
Okay.
Return the
Return the
distance.
distance.
Okay.
Okay.
So this is the
So this is
distance
the
formula,
distance
like
formula, like
normal
normal
distance formula, right?
distance formula, right?
X2 minus
X2
x1
minus
plus
x1
y2
plus
minus
y2
y1 the
minus
whole
y1
square.
the whole square.
So that distance
That
formula,
distance
that's okay.
formula, that's okay.
So if
So if
2 or
2
3,
or 3,
yeah, this is
yeah,
for the
this is
2
for the
points
2 points
basically, and
basically,
this is for
and
the
this is
3
for the 3
points,
points.
right, Uma?
Right, Uma?
Yes, yes,
So
yes.
yeah, 0,
Yeah,
1,
0,
1, 2,
1,
and
1, 2, and
2, 0.
2, 0.
That's okay.
That's okay.
For more than
For more than
3 points,
3
divide the
points, divide
points
the points
by
by
point around
point
the median
around
of
the
x
median of x
coordinate.
coordinate.
So yeah,
So yeah,
m equal to
m equal
x.
to,
Huh?
huh?
Sorry, Uma?
You
Sorry,
split
Uma?
it, no? That line,
Correct.
yeah,
Yeah.
Yeah.
X coordinate, yeah.
So we are
So we
splitting
are
splitting this
splitting this
right? And qx equal to px of, so this is going to be the left hand side part, and this is going to be the right hand side part of the px list.
Yes.
Okay, and x are minimum x value in rx, right? Yeah, that's okay. The minimum value in the right hand side. You want to see this? You want to see this
You want to see
visibly?
this visibly?
Px,
Px,
right?
right?
That's the
That's the
Px.
Px.
This is going to be
This is going to be
Qx.
Qx.
This is going to be. Okay, wait. I
Okay,
think
wait.
I
I
need to
think
print
I
it
need to
after
print it
this.
after
Okay.
this. Okay.
Rx.
Rx.
And I'm so
I'm
this is
so
going to
going to be
be Ex.
X.
R.
R.
Let's run this and
Let's
see.
run this and see.
Yeah. See, Px is nothing but sorted in terms of
Yeah.
x
See,
axis,
Px is
right?
nothing but
X
sorted
coordinate.
in terms of x-axis, right?
All right.
X
So
coordinate,
P
right?
like whatever. What was the
P
second one?
like
It
whatever. What
was
was the
nothing but Qx.
second
Qx
one?
is the
It
left
was
left.
nothing but
I mean
Qx.
the
Qx is
first
the
left, first off,
left
and Rx is
the
the
first left, first off,
second off.
and Rx is the second off.
Okay.
Yeah.
Okay.
And this
And
Q,
this
what is it?
Q,
Yeah.
what is it?
So
Yeah.
XR,
So XR,
what was XR
what
is
was
0 of
XR
0.
is 0
So
of
from the
0. So
Rx,
from the
from
Rx,
the right hand
from
side,
the right hand side,
yeah, from the right
yeah,
hand
from the
side,
right hand side,
the zeroth element
the
is
zeroth
20
element is
comma
20
1.
comma
Of the
1.
20
Of
comma
the
1, we
20
are taking
comma
the
1, you
zeroth
are taking
element,
the
which
zeroth
is
element,
20.
which is
Correct?
20. Correct?
Uma, are you able to
Uma, are
understand?
you able to understand?
Yeah, yeah, I got it. That is the median
The
to the
point
reference.
which is
Point
closest
which
to
is
the
closest to the
middle point.
middle point.
Okay, that's
Okay,
okay, totally
that's okay,
okay.
totally okay.
So for
So
P and
for P
Py,
and Py,
okay,
okay, the like
Py is the
Py is
order
the
sorted
order
based of
sorted
the
based of the
y-axis,
y-axis,
right?
right?
If P of
If
0
P
is
of
less
0
than
is less
XOR,
than XOR,
okay,
okay,
huh.
huh.
Okay,
In the x coordinate of in
yeah,
Py
yeah.
is less than the reference, right?
Mhm.
But I did not understand the code only.
I'll let you know
I'll let
this
you know
in
this
the next
in the
session.
next session.
Right, I was just
Right, I
trying
was
to
just trying to
understand what
understand what is
I
happening.
can
I can
understand what is
understand
happening
what is
here,
happening here.
right?
Right?
So delta
So
equal to
delta equal
minimum
to
distance
minimum
of
distance of
whatever and
whatever
minimum
and
distance
minimum
of
distance
this
of
one.
this one.
Sorry for the
Sorry for
sound.
the sound.
I just
I just
okay then.
okay
That's
then.
all.
That's all.
We shall do it
We
in the
shall
next
do it in the
session.
next
Like
session. Like
now I can
now I
understand
can understand
what is
this. What
happening.
is happening?
I can let you
I can
know.
let you know.
Next time we'll
Next
do
time
the
we'll do the
first at this
first
one,
at this one.
right?
Right?
Yeah, this S1 is the toughest part. Where we get the cross, no, afternoon point. The crossing points are very difficult to understand.
Yeah, it's okay.
Yeah, it's okay.
I'll let you know.
I'll let you know.
That's the easy
That's
one.
the
I
easy
can
one.
tell you.
I can tell you.
Right?
Right?
So once we
So
do
once
the
we
code, then
do the code, then
automatically the theory
automatically
part will
theory
be
part
easy.
will be easy.
Don't worry.
Don't worry.
So tomorrow,
So
that
tomorrow,
next time, that
next
will
time
be the
that will
first
be the
one,
first one,
and then probably
and
we
then
need to
probably
go
we
to
need to go to
integer
the integer
multiplication also.
multiplication also.
This is easy.
This is easy.
This looks
Yeah,
like
This looks
easy.
like easy.
yeah.
All right.
All right.
Let's see.
Let's see.
Fine.
Fine.
Okay.
When are we having the next session?
It's
It's
again
again
Tuesday.
Tuesday.
My
My schedule is
fully fixed.
fully fixed.
All right.
All right.
Okay.
It's probably
It's
next
probably
Tuesday
next
Tuesday,
only.
Tuesday.
7 to 9, right?
Yeah, 7 to
Yeah,
9.
7 to 9.
Okay.
All right.
All right.
Okay, guys.
Okay,
Thanks
guys.
for coming.
Thanks for coming.
Okay.
Afternoon.
Shall
Okay.
we wind
Shall
up the
we
call?
wind up the call?
Yeah, thanks. Yeah, thank you so much.
Good.
We'll discuss this in detail maybe in the next session.
Yeah,
Yeah.
sure,
Yeah,
sure.
sure,
All right.
sure. All right.
Bye.
So
Bye bye.
has Vikram joined today? No,
No,
not
no.
yet.
No, no.
He is going
He
out.
is going
He
out.
has okay, okay. He has some doubt regarding that